So, welcome back to the second day of DevOpsDays Vancouver 2017. I hope you had a good time last night at Tavern if you came out to join us. This would be the first time that they have actually turned off power in the entire block to get rid of us. Literally, the news article read, "Late night revelry cut short after rogue balloons cause power outage in Yaletown." So, made for an interesting end of the night. A little dark. It was great to spend so much time meeting so many of you and see the lively discussions going on between everyone. Hopefully all of those that need it received their coffee this morning. Thank you, EA, for the coffee sponsor. We're going to keep this pretty short today and move on pretty quickly to our speakers. This may mean our schedule moves up a little bit. Typically second day, we just move it along. We've got 6 amazing speakers today, plus Ignites, and then some open space as well, so lots to look forward to. First up today, we welcome Jeff King from Brains.io to share his experience with the rapid growth they had in 2016. Come on up, Jeff.
Hello, thank you. Yeah, I'm Jeff King. I was working on Brains.io, but I actually work at Microsoft, so sorry for the deception. Good morning, everybody. I hope you're not too hungover. That's the clicker. Okay, so Brains.io is a game, all JavaScript-based, played in your web browser, at least to begin with. It's really nice, kind of simple game. You get in there, and you either are a human or a zombie, and you try to turn people either to humans or zombies, depending on what you are. It works really well for like multiplayer, which really helped in gaining some traction with it. This is what it looks like today. The journey that I'm going to kind of take you on is more the first 3 months, and really kind of how I came to find Brains.io and help out, as well as kind of the journey we had for a few months in trying to meet the demands of the game. So we ended up running with about 3,600 concurrent players, and that took about over 200 cores in 4 data centers across the world. We ran this all on Microsoft Azure for a few reasons. Also, because it's all WebSocket based and there's just a lot of chattiness happening, we were running like 300 terabytes, and that's just data going out, so probably about double that, which is about 100 megabytes sustained throughput from our clusters. This is all in kind of the first 3 months, and it was pretty fun and pretty challenging to meet this in the first 3 months. So this is really kind of before my time. This is before I'd met the founder and writer of the game, Jae-yoon, who I'll get into in a little bit. But this is really his first 2 weeks of growth. And so he had Google Analytics there, so we could kind of see what was going on. And just before I met him, he started to see a couple swings up. And this is with absolutely no marketing, a little bit of word of mouth, showing some friends the game. It ended up on Reddit. People started V-blogging it and putting it on YouTube. Things like that were starting to show that there was traction happening in the space. And prior to this, I mean, it's kind of funny. He got a little bit burnt out with his job and went to Thailand for a few months. And he was kind of like, yeah, I just want to write a game. So he sat down for 3 weeks and wrote this game. So the whole engine is based on an open source engine in Node.js. He wrote probably about 1,500 lines of code, really. I mean, there's some HTML and CSS, and his sister designed the assets and things like that. But we're talking like about 1,500 lines of code before actually just putting it out and starting to see like 10,000 users a day come to the site and hit it. So getting into Jae-yoon a little bit. So he's the guy here on the left. So he's an interesting guy. He's a serial entrepreneur. He's probably had about, I think he said about 12 startups, probably including this. Even since Brains now, he's had about 3 other games released in the last like 6 months. So he's a pretty active person. We actually met him. Microsoft is doing hackathons with partners. So we sit down with them and we write code and we help them implement things. So he actually came to us for a product that he's been developing for 5 years, which is like hotel management software. And this is the kind of software that he got a little bit burned out on. So he'd been doing that for about 5 years. And he came to us, and so we helped him with some problems. And it was kind of funny because at the lunch break, he was like, I have this little side project that I'm doing, and all my servers are blowing up, and what do you think about this and that? And that's like really the problem that I got really excited about, because the stuff we were doing here was pretty straightforward, moving a little bit of SQL Server and getting some web pages to render. I mean, I really like to see like servers blowing up because of demand. That makes it a lot more fun for me. So we did this hackathon with him, and it went well. It was based on the other product, but it got me thinking in the back of my mind on how I could help with this game. So first thing, too, just to be clear, once you start running this number of servers, there's definitely some cost involved. The nice thing that I can do, or Microsoft can do, is we can bring money to the table. And so we're able to run all of his infrastructure for him for free. There is obviously cost associated with it, but we run this program called BizSpark, and it's really for startups. And we really like startups that are, growing like this, so we really try to help them out. So we were able to basically fund all the tech side of this project. Which is really helpful when you're an entrepreneur and you're just trying to test things and see what's going to work. And so he had that already in place when we started to actually, when his game really started to ramp up, he already had that funding in place, which was really, really lucky. But if you're ever in a situation where you need some, just come and talk to me. So this is really kind of where I truly walked into Brains.io. And I mean, this is a little bit funny, but the idea here being is he had, I think, just over 20 servers. He was using quite large servers at that point, so at least 16 cores or more, so pretty large servers running quite a bit of Node. Primarily when I'm talking about the servers, I'm talking about the Node, like the back-end game engine clusters. The web serving part of it was quite straightforward, but the actual game engine was taking a lot of CPU. So this is what his servers looked like to me. He had full server crashes, lots of outages. When he was deploying, he'd be deploying onto multiple websites onto every single box. So in 20 servers, I think he was in 2 or 3 regions, he'd SSH into every single VM and do git pulls on every single repo that he had on the box. That's how he was doing it, right? But I mean, this was all spawned over just a couple weeks. So it started with 1 VM, it was like, yeah, good idea. And then he needed more capacity, he's like, oh, I can do 1 more. And so when I got in here, he had over 20, and deployments and not knowing the version, where is what, was like, whoo, stay away from it, right? So I walked in, and my first order of business is I don't like working with VMs, period. I know it's really VMs all the way down, but but just the management was becoming a serious issue. So we kind of started looking at it like we got to get rid of these VMs, or at least make them way more manageable. So we got together, and it was Vancouver Startup Week, and there was a hackathon going on, so we kind of used that as a weekend. This is about a week after I'd met him. Yeah, it was actually about 3 days after I met him, but that's fine. So we used Vancouver Startup Week to block off some time over the weekend to really get down on the issues. And the first thing we did was sit down and just kind of dreamed up, what can we do radically different. We ended up landing in a fairly similar place to where he had, because the game engine was open source, and we really didn't want to touch the code because it is a very complex piece of code, and we really wanted to, make sure things it was going to run on Linux and just keep it on the same, as much of the same as we could. But really start to open the door and look at containerization, and that's really the route that we went. So we ended up, throwing it onto Docker, doing a quick, over that weekend, really, I'd taken time to learn about Docker, but this is really the first time that I was stepping up to put it into production and stuff. So, just took time over the weekend getting it running, testing things, making sure that worked over the weekend. And then we really had to change kind of just one piece of code in the system, and that was when a game engine was coming up, it would actually need to register to show capacity to the users, and that was really the only code change that we truly needed to make to the system. Outside of that, the game engine's quite isolated, which is a good thing in terms of scale. And it's good that there was no state being held anywhere really in the game. So we could just like add as many additional containers with the game engine in there as long as they were self-registering, and that's all we really need to do from the actual dev side. So my role in this overall was really kind of small dev, big ops, while he was really focused on the dev and making sure that the game was awesome and that he was able to continue to add features. So we moved on to Docker because it's cool. Yes. And Docker, or Docker Swarm, Docker's good. I mean, definitely images, and there's a lot of good things about Docker. But I did find quite a few kind of challenges in learning Docker. And just the orchestration of it, I thought there'd be more like magic built into it. I think Kubernetes is doing a much better job at this point, but it worked for what we needed. We ended up doing, or continuing to do, a lot of like, I guess, manual stuff. But we were able to implement, so we had 4, I guess you call them swarms. We had 4 clusters up in 4 data regions. We're moving on to the swarm in about 3 days. After about 5 days, we had completely shifted the environment over to Docker. So this is, yeah, a few days in. We're both excited. You can see we're just command lining everything and have everything now actually running. And even at this point, I mean, we were able to add capacity in a fairly straightforward way that would add like linear scale, which is really what we needed. But even at this point, we still had like lots of crashing in the application and things like that going on. So this was really kind of a first step to really kind of unblock the need to add compute. So I always go back to when I'm talking about scaling. I mean, I think engineers, and I put myself in this bucket, we always talk about, yes, the software is scalable. To me, it's really about the human side. Like, are the humans who are behind the systems able to scale the systems in response to like what's going on? So this becomes just super critical. Communication, communication, communication. During this whole process, I mean, looking a little bit forward from where we just were, we started, he had like Discord in place. I don't know if anyone's used this. I think it's kind of used in gaming and stuff. So we started just chatting on Discord. We ended up kind of falling onto Skype all the time because he's just on Skype with his fiance like 24/7. So then him and I would be talking on Skype. It doesn't really matter the channels. The other thing is we would pick up the phone and call each other, which is like in this day and age, pretty unique. And sometimes that would be at 3 a.m. too. So the thing would be though is you need to really communicate what's going on. We were, so I still like, you know, continue to work at Microsoft. He continued to work on the brains. He like flew to Germany. I was in Africa. We were in different parts in BC, Alberta, wherever, and we were getting all this shit done. It really didn't matter, but the key here is that we were always touching base whenever needed. We kind of got it to a place where like the scale was kind of plateaued and we both could scale it up and down pretty easily, but we'd still be talking behind the scenes about what was going on and what we thought was going to happen. Things like video blogs would come out. So if a video blog came out with like someone with like 1 million followers, we'd need to like talk about that and then think about planning for the next couple days. So I just want to underline like communication, communication, communication. So he had always put Google Analytics in place, and you know, analytics really drives everything that we did. So the Google Analytics, from my perspective, really gave us this. This is all I cared about on the scale side, and this is really how we knew where to put our data centers. You can see there that we're like super hot in Brazil at this point, and that was really done by like one video blogger in Brazil, and then he had hundreds of thousands of followers, and then other people would put videos too. So he was like, it was pretty crazy in Brazil. Comparatively, like North America was way less. And then we saw more and more growth in North America, Europe, and then our other cluster was in Asia at the end of the day. Asia was always relatively small, and Brazil was like always competing with North America, even though you typically see more gamers happening in North America. And so also when I came in and started doing some of this work on the dev side, I was, so this is a Microsoft product called Application Insights, but I was really big on putting telemetry into the application so we could really understand why it was crashing. So we started instrumenting various pieces to get the analytics out of it. And so we ended up with dashboards like this really quickly. This one's really kind of showing the capacity that we're at in our clusters, so just showing overall CPU usage, with the idea being that if we're hitting about 60%, then we start scaling up, right? So that was the big thing to begin with, and then we have some deeper telemetry there. It's really hard to read this stuff. But yeah, just starting to understand how our systems are actually operating became very critical. And then the funness too. So as we started scaling up and getting near like the 200 cores, we really thought that the game might get really big, like Flappy Bird. Flappy Bird it was pretty amazing how big it got, but so we started to provision like hundreds of cores in these regions, and then we started hitting the roadblocks. On Azure, there's just caps that are based on, they don't want people to go in there and spin up like 10,000 cores and not be able to pay for them, basically. So we started support tickets in all of the data centers and saying, like at a minimum, give us like access to 1,000 cores per data center. We never really got to that scale, but we got all that done a little bit ahead of time just to make sure that we had access to as much CPU as we thought we might need. And so this is kind of how it looked in week 3. So we started getting to 100,000 users per day. So this is kind of just like people coming to the site. You can assume that they're playing for, I think the average time is about 3 to 5 minutes they were playing at this point. So 100,000 people coming a day was pretty good in week 3. And because we were just hacking shit all day long, this is really how we ran the business. First off, I mean, I always fall back to like, Excel kind of runs the world. So we were just doing like string building commands to deploy to Docker, to be very straight. Like we just had a page for like Brazil with all the containers we wanted to run, and we would just have pages for each data center. All we do is SSH in, just run commands, just pump those containers out. And this is all we did. And we did this, yeah, for probably like 4 or 5 months. It got automated kind of in the new year. But the auto scale was like humans. That was the auto scale. And the generation of the commands, just to make sure we didn't introduce any issues, was all in Excel. So just to understand when the right time is to like, put effort into that. For us, the focus was primarily on just making sure that we could scale, because we were able to kind of anticipate a lot of it. And then also because it was free, we just over-provisioned a little bit. Free, yes. For me, this was my first time really putting Node.js into production, and Node.js is just so badass. I had no idea. So, like I said, I'm from Microsoft. I'm, primarily a C# developer, but Node is badass. So you probably can't really read these stats. So we had 2 APIs. So I mentioned that we'd have the game engine come online and like self-register. So these are the APIs for the registration. Up here is a get, so that's just people polling to see what servers are available. So we have like 2.5 million requests there with 15 errors. So I think that's a pretty decent error rate, and we have like a 3 millisecond response time. So that's just backed by Redis, which is the next point. Redis is badass. These are also run on Azure in like kind of the cheapest. Like pretty low levels in terms of like performance and everything too. So these are like both just run on managed servers. And we only had 2 instances for the Node.js stuff, and then the Redis is all managed. And yeah, it was crazy. I mean, these are just things that never gave us any issues in terms of the scale demands that we were trying to meet. And just millions and millions and millions of requests. So weeks 4 to 10, we started to stabilize a bit, as I was kind of alluding to. And so we were able to kind of keep the provisioning correct within the data centers pretty easily. Within there, we'd see some spikes during the day. But overall, it was pretty stable. And, it was at that point that there was kind of some time where they could, and it wasn't even me who started to automate this stuff, but where people kind of came back in and started to automate some of the processes around this. And the other thing that because I was focused on the op piece, it really left Jae-yoon to like really continue to develop the game, which he really needed to do, because he only had developed like 3 weeks before release, and then at the early stage there was only like a month or so where we were dealing with scale. He needed to continue to refine the product and make sure that what the players wanted to do, he was able to kind of add those as features. And yeah, today it's on Android and iOS if you want to download it and play. Yeah, it's a pretty fun game. And so I really give this talk because to me, when I saw what was going on and just the amount of how empowered we are today, being able to access these servers and these data centers all around the world is really amazing. And even I work with a lot of different companies. It was really amazing to see his idea really be global and so fast. And I really just he kind of just sat in a basement for 3 weeks and developed an idea that he'd had that came out of a game that, or a map that he developed in Warcraft 10 or 15 years ago, I think Warcraft 2 or something, that he thought was fun. And he came up with this game, and all of a sudden he had hundreds of thousands of people playing it. And he was able to generate revenue off of it. I think he was peaking at about $1,500 a day, which is pretty decent, over 1,500 lines of code. So really, it just blows me away that we can do this today. I mean, I just think it's amazing, the industry and the space that we live and work in. And yeah, and today on YouTube, there's over 30,000 videos of people playing this game, which is pretty crazy. That's a lot of people who have logged in and played and shared it, and that doesn't include streaming services and stuff. So this is me. If you ever have any scaling issues, you ever want to talk about this, please hit me on Twitter. Always interested. If you're ever interested in Azure or getting some free credits to Azure, let me know. I'd love to help out. Yeah, that's my talk. I don't know if anyone has any questions. Come and find me at the break if you do. Okay, yeah. Shoot, I'll try and repeat it so people can hear. Where is the game state persisted and how do you scale that? So there's no game state. Well, originally there was basically no game state. It lived within the game for the duration of the game. And the games are minutes, they're pretty short. He's releasing a beta right now, which the state's stored in a Mongo database. Yeah. But that was the one thing when we met at Vancouver Startup Week. That was the first thing that yeah, I was able to look at and we kind of talked about, and we were actually talking about adding a state at that point, and it was the worst idea that we could have done. So I'm glad we didn't. The only state that we had was in the Redis cache, which was the server registration, and then everything else is just telemetry coming out of the system. Shoot.
Could you guess at how much it would have cost to run that had you not had access to turn off billing for it, basically?
Yeah. No. It's free. I mean, it was free, but you see bills. The craziest thing at peak, when it was at peak, and I really underestimated, was the bandwidth cost. But we were running $10,000 to $20,000 a month. Yeah. Yeah.
Why you didn't start with web app on Azure and you go straight to the Docker?
So the piece, so we had the actual HTML serving, and then we had the APIs, and those were on an Azure web app or app service. And then the back end is really, everything's socket driven, so we needed a ton of sockets. And we didn't want to introduce too much change. So the idea of keeping it on a VM, but just keeping it not messing around with it too much, really. So that's why we were Docker was the smallest step forward that would really enable us to more easily deploy and control the versions. Yeah.
There's nothing wrong with web app.
No, it's not. No, it was. We talked about big steps like Microsoft has a technology like Service Fabric, which you can add state to and things like that. But the Linux support wasn't GA'd yet, and so we just stayed away from anything like that. And really. Moving to Docker also gave us the ability to move from 16 core VMs or big VMs down to we started with I think 2 core VMs and then decided to kind of run it on 4 core VMs. So that as our stepping function was smaller, our step ups and our step downs were smaller, right? So we made some choices like that, but yeah, I don't. We were using ACS, so Azure Container Service, and we had ARM templates, which are infrastructure as code, so we were able to add and remove from the clusters in, I don't know, 30 or 40 seconds. Yeah, just through a command line. Shoot.
Is there one thing in this process that you would say, man, I really wish we didn't do that, or would have done differently?
You know, not really. I mean, after a couple months, you're kind of frustrated with like the copy and paste manual stuff, but at the same time, like if you just go to over automate too quickly, then you're probably just going to waste time there. We definitely like hit issues, and you know, we would try things and it wouldn't work, and then we would, you know, try another route. The manual processes are kind of frustrating, especially if you're like a software developer, you're always thinking like DevOps terms. But I would prefer like manual, and then like once you know exactly what you want to do, then automate that. And then your testings are all like, you're just wasting that manual time, not the time to implement automated processes that fail. So we didn't have, I mean, I wish I got to them sooner. And still now too, because I'm very focused on like how would you scale the systems. Like he's running Mongo now, and he's doing it in a way that I'm pretty concerned about because he's about to drop buckets of users. Like right now in the beta site, he has, I don't know, maybe 100 users running it. It's going to be very different if he gets like 3,600 concurrent, and if he has growth on that and it becomes 10,000 concurrent. I mean, I kind of watch what he's doing. I'm like, oh, okay, well, we'll deal with it when we hit it, but he just wants to like write the best game ever, you know, that's his focus, right? And I just want to make sure that people can play it. So I think there's about 10 seconds, so I'll just wrap up here. Thank you, everybody. Have a great day, and then you can find me in the break if you have any other questions. Thanks.
Well, it definitely sounds like you had some pretty interesting challenges there. That sounds super fun. I'm like, yeah, I want to go home and set up something like that. Except for the game part. I'm not a big game writer. But all the rest sounds fun. I'm like, yeah, stand up a bunch of infrastructure. I dig that. So next up then, we have Holly Burton to take the stage, a career coach and a mining engineer, to shed a bit of light on a tougher topic, gaslighting in the workplace. So welcome, Holly.
Got the wrong one. Yeah, the new one's on here, though. Small technical difficulties, guys. Just a sec. Yeah, it's a PowerPoint. Yeah, that one. Oh, shoot. Okay, only if you say, oh God, that's awful. Give me the PDF instead.
I think you'll like this better.
Do you?
Trust me.
Can we hook up my laptop?
Yeah.
All right, it's fine. So the fonts are going to be a little bit crazy. Hopefully this turns out okay. Yeah. What is that, Times? Excellent. Okay. So hey guys, how are you guys all doing? You look pretty sleepy this morning. It's a quiet crowd. Yeah, I'm excited to be here at 9:45? My God, whose idea was that? Yeah, so I'm excited to talk to you guys about gaslighting and gender in the workplace. I know it's really uplifting, so let's get the day started on a depressing note and keep going. So as you guys already know from yesterday, I'm Holly. I'm a career coach that works with women in male-dominated industries. My background is in mining engineering. I did that for 10 years. If you want some stories about giant yellow haul trucks, I've got you. I'm also a huge feminism nerd, and hence my interest in this topic. So before we get started, what we're talking about today is certainly not framed in a gentle way, like gaslighting is an emotional abuse tactic, and I'm talking about how it applies at work. So the thing I want to say up front is anytime you're talking about whole groups of people, like for example women, half of the population, I'm going to be making some generalizations. So this may not match exactly your experience or exactly the experience of people that you know, which is totally okay. Just stay open to what I have to say, and I'm happy to chat more about it later because, you know, by its nature, there will be stereotypes, right? Okay, so I want to talk about that question, am I the crazy one? That's the whole title of the talk, right? So you might ask yourself this question when you're totally alone in a viewpoint, like if you're the only person that has a certain opinion at work, and when you try to explain it to somebody else, just nobody gets it. And it doesn't matter what you say, it doesn't matter how you explain it, if you use pictures or words or emails, just nothing really pans out for you. And another key thing to look for is when the solution is just like super obvious to you and everyone else is like, nope, I don't see it. Have any of you guys felt that? Yeah, okay, so a couple people in the room who are clearly my people, because this happens to me all the time. So if it just happens to you once in a while, it doesn't really matter, right? We all have that. It's like, it's no fun. You go home, you probably complain to your significant other if you're anything like me. But you live through it. You're just like, God, that was frustrating, but it's fine. If this happens to you all the time, though, you really start to ask yourself that question. Like, God, am I the crazy one? Like, maybe it's me. Because I keep being the common denominator in all these situations where people just can't understand a word I'm saying, right? So that's pretty brutal. So if that's true and you are the crazy one, maybe your ideas are just awful, maybe you just have terrible viewpoints, or maybe your communication style is just totally sucky and you can't get a word out properly. It could be some other reason, I don't really know. Ask your friends, maybe they could tell you if they're feeling a little bit mean that day. But what if that's not true? Like, what if you guys actually do have a valid point? What if the thing that you're saying does matter and you don't communicate poorly? What if you already know that to be true about yourself? Well, then what might be the reason? So what I want to talk to you guys about today is really around this scenario. When you're not wrong, your communication style doesn't suck, but no one else will really pay attention. So that's when we're going to talk about gaslighting. So gaslighting is the denial of a person's lived experience such that they begin to doubt their own perception, judgment, and sanity. So basically, if I have an idea and I feel strongly about it, or even more obvious is when I have a feeling, and I'm like, this is how I feel, and someone else says, no, you don't, right? That's a very clear indicator of gaslighting because nobody else can really know what I'm feeling or make my feelings invalid. They may not feel that way themselves, but they certainly can't tell me that the way that I feel doesn't exist. So this will show up in a bunch of different ways, but either way, one of the key elements is that it'll happen so much that you start to wonder if you're the crazy one. So I'm noticing some parallels there, right, between gaslighting and the scenario we talked about before, where no one will really believe you, and no matter how you try to explain it, it doesn't pan out. So this starts to feel familiar with gaslighting. So maybe this is what might be happening, right? So let's talk a little bit about some of the more subtle dynamics of gaslighting. One thing that's really important about gaslighting is that there's a power dynamic involved. So it's a lot easier when there's an imbalance of power. So this could happen between adults and children. It's actually very common in adult-child relationships or parent-child relationships. It also might happen with bosses and workers, or even people who are senior and junior to each other at work, because you have somebody, just like in a parent-child relationship, who's in charge of helping somebody with their development, technical or interpersonal skills at work, or with the example of children, like basically raising them up to be a competent human being. And so that person relies on them for feedback, right? And there's a certain power, privileged position that the person, the boss or the senior or the adult knows more than the person in the less powerful position. So it's an easy setup for that kind of dynamic that'll make you go like, oh my God, this really experienced person feels totally differently than me. Like maybe there's something wrong with me then if I don't perceive it the same way as them. And you even see this in therapist and patient relationships. It's really interesting because you go, well, therapists would never try to gaslight somebody. That's the core of what they're not supposed to be doing as a professional. But because of the dynamic, especially with people who have mental illness, they're relying on that person to help them interpret the world, right? So this will show up even there. So I'll imagine, if you guys haven't seen this pattern in your life already, you'll start to see it pop up after we talk about it today, because it does happen in different places. And a key thing is that there's an advisory nature to that relationship, right? So you can see in all of those relationships that the person in the powerful position is giving advice to the less powerful person. Another thing I want to talk about with gaslighting is something that I'm calling the outsider effect. So this is where, for example, I'm a girl, I walk into a room, like any room at this conference almost, and I'm the only one there. So I'm the only one with the set of experiences that I've had for, let's call it 29 years, living, it is 29, let's be clear. But I've had 29 years of experience living in this body and living in the world as a woman, right? So I have a totally different viewpoint than most of the rest of the people in the room, and there's lots of commonality there. We all live in Canada, and all of us probably watched Animaniacs, let's say, when we were kids. I don't know. Yeah, Animaniacs. But we have lots of things in common, but there's part of it that's just different. And when you're only one or two or a small percentage of the room, you by nature sort of already have a dynamic wherein people are not primed to fully get you, right? So we'll see this more on diverse teams. And the interesting thing about diversity, I don't know how much you guys read about this, but part of the business imperative for diversity is that by having more diverse teams, you avoid having groupthink and you come to better decisions, because every decision that's made, in theory, gets more well examined by people with different viewpoints, right? So this outsider effect probably does show up on your teams and has a real business effect for the people that are in those positions. And it, I would say, also enables gaslighting, because you have that dynamic where somebody's coming from a really different place. Make sense? Cool. So at work specifically, some places you can look for this to show up are in performance reviews. That's a really, really fraught area, because there's somebody actually giving advice to somebody else about, you could frame this differently, but effectively what's wrong with them or what's not working as well about what they're doing. And the implication is sort this out or you'll never be successful here, or sort this out so that you can be successful here, right? And it's done by somebody in a higher position like your supervisor, right? So you might see this here in particular. There's a ton of research. I could go on for hours about it. I won't now. But there's a ton of research around the differences between men and women in performance reviews, and how women's performance reviews are actually more commonly about personality traits rather than behavior. So in particular, when you're talking personality versus behavior, that makes it a really interesting area for gaslighting, because it's not just something you're doing, it's cutting down to who you are, right? And gaslighting is sort of about who you are as a person, not being correct. You'll also see it when proposing ideas. So that comes back to that idea of the outsider effect that we were talking about. So when someone says like, oh, I have an idea, what if we make, then this is a really stereotypical example. I'm sorry, it's the best one I can come up with right now. You probably have better ones. But what if we make our female game characters not wear a bikini? Or maybe be, a little less boobtastic or something like that, right? And people are going, well, we want to sell games and that's kind of how it is. And, have you seen these last 15 that came out? I just don't think it's a problem. And you're going, but, the Twitter storms and girl gamers getting tough lives. And it's like, not a business imperative, move on. So that's an example of a time when proposing ideas can be influenced by that outsider effect and have that same sort of gaslighting thing, like, oh, cool, that's your point of view, nobody cares, right? And you'll also see it in interpersonal conflicts, when you and somebody else just differ in opinion about how to get something done. And maybe it's a light disagreement, or sometimes I'm sure you guys have experienced when you're just like, that person's wrong, they're the worst, there's no way that this can be right. People can get pretty heated, right? So you'll sometimes see it there in interpersonal conflicts on different genders or even the same gender, where people will go like, nope, I just don't get your point. I think it's a giant waste of time. And you're crazy to even hold it because it doesn't make any sense. So you'll see gaslighting behavior start to show up there. So something that's really important for you guys to know about gaslighting is that a single incidence of this doesn't really make gaslighting a thing. If this happened to you one time in your life, I wouldn't say that you're just this giant victim of gaslighting and it's going to have these huge effects on the rest of your life or anything like that. What really has to happen is this has to be repeated. It's subtle, right? Like, this is not something that is always super clear. So it has to happen again and again and again for somebody to really get down to that level where they're like, oh my God, am I insane, right? Like, one argument doesn't make you feel that way. So repetition is really key. And most people aren't out there trying to be manipulative monsters. Like, do any of you guys go into work going like, yeah, I can't wait to manipulate some people today? No? Just me? Okay, there's a few. Thank God I'm not alone. But yeah, most of us, except for us three, are not really that way. We want to go in, we want to do good work, we want our coworkers to like us, we want to have good relationships. So we don't set out in the morning like, oh, I can't wait for another day of gaslighting, this is going to be great, right? Granted, there are a few people like that, not just us, but others. But most of us aren't really there. So how the heck does this happen? Like, it has to be repeated all the time, and you have to either be a monster or accidentally doing this constantly. You're just like, oh, this probably won't ever happen, right? So the repetition doesn't have to be recent. You can actually be preconditioned to have this particular response. So if many times in your life your opinions have been invalid, you're more likely to reach for that, oh, maybe it's me, maybe I'm crazy, right? So you might have a history with this type of abuse. I mentioned earlier that this is actually an emotional abuse tactic, and that's true. So people might have been in emotionally abusive relationships in their past with parents or relatives or even romantic partners. I can definitely think of one friend in particular right now who's in a relationship like that. So, this is probably more common than you think, and people might come into the workplace just already pre-exposed. And you'll also see it in communities that have traditionally been marginalized or in a less privileged position. So women, I think, fall in that category, but as well, minorities of every type, right? We have that experience of, well, not that women are a minority, actually, we're a little more than 50%, but we have that experience of having to defend our point of view as correct quite often, right? Or having that point of view completely ignored. So you might be dealing with somebody, there might be the odd incidents of this, but because of their past history, they might actually reach for that am I crazy question or explanation pretty often. So you don't have to just be a monster. So speaking of gender, some of the things that lead into or play into gaslighting with women in particular at work is the traditional power dynamic between men and women. Whether or not we feel like sexism is over and 2017 is the new frontier, I don't know. But women have really, for a long, long time, had a less privileged position in society. I'd argue they still do. But it's only in the US in the 1970s that it became actually a thing that you could rape your wife. It was impossible legally before because she was your property. Women only got to vote, in the early part of last century. There's still huge battles going on around health in the US for women's rights. And all of that legislation is being passed by old white men, right? So there's been traditionally economic differences as well, I'd say, with men being the head of the household. Like if you look back in the Mad Men era, kind of, right? Women weren't economically empowered and actually didn't even have the power to get a divorce. So there's long been this power dynamic between men and women, and I would say that today, a lot of power, even though we have a much more equal society, and things have changed a lot, there's still a ton of power concentrated in male hands. If you look at, every single Fortune 500 company, I think there's 2 CEOs that are women on those. And if you look at American politics, the most powerful country in the world, or actually any politics, I think it's 30% of countries that have had a female leader ever, like just even one. Including Canada, we had Kim Campbell for 4 days, very little time. So there's still this power dynamic, and even to the extent that it doesn't exist today, the fact that it has existed for so long has affected how we've been raised. We've all been raised by people who were in that system, and it's part of the culture that permeates. So that power difference that we talked about earlier with gaslighting comes into play with women and men just sort of by virtue of our culture. Another thing that historically has been true is that women's opinions and voices have been given less value. So the most common thing that people will talk about is that phenomenon in a meeting where a woman will say something, here's my idea, nobody cares, and then 10 minutes later, someone else will say it, and suddenly oh, great idea, Steve. Have you guys seen that happen in a meeting? I have. Okay, a couple, yeah. That's the common one that people reach for, but you even see it, there was an article going around a little while ago, maybe last year, about the Obama administration and how the female people in his administration had finally cracked the code that if they just keep repeating the same idea 15 times, then Obama's oh, what a good idea, right? So it does happen, and Just within this last week, Amal Clooney, who's a human rights attorney, went to the UN to talk about war crimes going on in Iraq and systematic slaughtering of people there. And Time magazine was like, Amal Clooney shows off her baby bump. So what a way to devalue women's voices, right? And when Theresa May and the German Chancellor met up just last week to talk about Britain leaving the EU, the headline was, who cares about Brexit? Let's talk about their legs. Who's got better legs? And if you look up on Twitter, Legsit, then you can see a lot about that. People were pretty pissed. So this happens in subtle ways and in the really overt ways that I've just talked about. And if you'd like some more exploration on this, I'm happy to talk to you guys. But generally speaking, within society, women's voices have less value, and our opinions do too. There are also some specifically female-coded behaviors that women are just trained and expected to do from a young age. So emotional caretaking is one of those things. So if I walk up to anybody, I'll be like, how are you? How was your day? Or even when I came on stage, I was like, God, are you guys tired? You look tired, right? So that's an example of emotional caretaking. And women are also traditionally meant to be the peacekeepers, right? We'll subsume what we want to keep the peace. So you can see in both of these examples how when we're supposed to emotionally caretake and subsume our needs to keep peace, how that might play into gaslighting, right? It really allows us to take on that identity of, oh, they think my opinion's wrong, I don't want to fight with them, and so what I'll do is allow that to happen and just take it on myself and go, well, maybe my opinion is wrong, perhaps I need to correct that because it's endangering the relationship, which women are taught from a young age is supposed to be sacrosanct. How you guys doing? Is this uplifting enough for you yet? Good. Okay, so in more exciting news, let's talk about the emotional effects. So emotional effect 1 is self-doubt. So you might doubt your perception, you might doubt your intelligence, and you can even end up just doubting your worth as a person. And I just want to take a second to let that settle in the room, like, oh my God, doubting your worth as a person, that sucks. Like, I almost want to cry thinking about that, like that somebody would end up at that point. It's really awful. Shame is also another effect. And there's a difference between shame and guilt. And if you guys want to learn more about this, you can watch Brene Brown's TED Talk or read any of her books. She talks a lot about it. But guilt is when you feel you've done something wrong. Shame is when you feel you are something wrong. And there's a really big difference in emotional weight between those two. And gaslighting is playing into the shame aspect, that you are something wrong. Fundamentally, who you are is broken. People, for obvious reasons, given the above, end up getting quite depressed when this goes on. And it also creates a dependency on the gaslighter, since you can't understand the world yourself and you're so bad at it, but this other person is an expert, you'll keep going back to them for that interpretation, and it actually perpetuates the cycle. So in terms of practical effects at work, what you might see is people who feel like their ideas aren't worth fighting for, so they stop fighting for them. And that's exhausting. Like having to do that every day or every week or every anything, having to feel like you're doing that all the time is so tiring. So they might just kind of go like, ugh, I gotta check out of this. It's too hard, it's really fatiguing. And from that, you'll end up with people silencing their viewpoints and opinions. And we talked earlier about how part of the push for diversity and the value in diversity is having those different opinions. So this is something that enables squashing that, which is really, really sad. And you'll also see people not put their hands up for high-profile projects because it makes them more visible and makes them more liable to this type of attack, which is pretty emotionally devastating, as we already discovered. So that behavior makes total sense. And as a result of, being quiet, not ever saying anything in a meeting, and nobody knowing who you are or what you think, and never taking on any high-profile projects, you'll probably have less of a chance for a promotion and a raise. Not to mention the fact that if you feel like you're total garbage, like, are you going to go to your boss and be like, I'd like a raise, please? It's pretty tough, right? So these are some of the effects. This is what it really translates to in real terms. And another effect that I would contend comes partially from this, although not totally, is that 50% of women in STEM fields leave within their first 10 years of their career. 50%. It's crazy high. 40% of those leave within the first 7 years, and 30% within the first 3. So these are women who have spent, 4 years on a degree plus 10 years working, and they're like, nope, this is too hard, I'm gonna leave. 50% of the people that do leave end up using their skills in self-employment or working for the government or something like that. But 50% of them just up and leave the field and find jobs elsewhere. It's not that they're like, I'm gonna go be a stay-at-home mom. They still wanna work, but they leave because it feels hostile. So this is kind of the emotional context and work context that I wanna give you guys for this type of dynamic that happens at work. And look, all of us will probably at some point find ourselves the gaslighter. I mean, I can think of an example that happens at least once a week of gaslighting between my boyfriend and I. He's very ticklish, only sometimes, it's super annoying. And so sometimes I'll touch his arm and he's fine. Other times I'll touch his arm and it tickles. And he'll like, don't do that, it tickles. And I'm like, it doesn't tickle, right? So that's crazy. That thing that I do, it's actually quite harmful to him, right? But you guys will one day, I'm sure, like I have, look at yourself in horror and be like, oh God, I'm gaslighting. Holly would be so ashamed of me, right? Or myself would be so ashamed of me if you are Holly. But yeah, it'll happen. It's not the end of the world if you do it all the time. Maybe you're one of those 3 monsters like me in this room. But yeah, it does happen, and I think it has real effects on our workforce. So if you guys want to talk about this a little more, I'm around. I'll probably propose an open session later on. My contact info is there, and I'm happy to talk to you guys about anything you'd like. And we can probably take like one question. We have 2 minutes and 30 seconds. We're a little ahead. Okay. Questions? Yeah.
As someone who's probably gaslit someone else, what tips could you give to people to become self-aware that they might be doing this?
Right.
Gaslighting isn't, I wouldn't say, very well-known term. It's like a year ago.
Yeah, so the question, guys, for those of you that had trouble hearing was, if you're worried you might be doing this, what can you look for? So the key points are that you're invalidating somebody else's lived experience. So if you ever tell somebody that their feelings are wrong, like, guaranteed that's gaslighting, like for sure, because you have no idea what they could feel. And so the difference between, I guess, asking a question or not agreeing with somebody and gaslighting is, if you ask a question, you can say like, oh, I don't really get that viewpoint. Can you explain it? What does it mean? And they might explain it and you'd go like, it just from here doesn't seem like it really exists. I'm sure it does for you, but it doesn't make sense to me, right? So that's an example of taking in somebody's opinion, valuing it, and still going, it doesn't really land, versus me going, like, no, I don't think that happens, right? And the other person's left going like, well, it does, so now what are we gonna do, right? So being more careful around your framing will help you not do it, even in situations where you don't necessarily agree. But yeah, look out for that moment when you are invalidating someone else's experience, and especially in kind of a harsh and definitive way. Gaslighter is usually pretty confident, so if you, I am the type of person that can pretty easily, in a meeting, derail the whole thing and start running it myself. If that's you, pay extra special attention, because it'll be easy for you to slip into it. Anybody else? Yep.
Some people are predisposed to be susceptible to gaslighting. Are there people that are predisposed to gaslighting?
That's something I actually couldn't answer. It's a great question. So I would posit that, the thing I just said, that it's easier for people who are really confident to do it. It's hard to gaslight somebody if they're like, here's my opinion. You're like, well, maybe you're wrong, right? Like, that's just not going to make somebody doubt their sanity too much. So there's that certain amount of confidence that I think is a part of it. But I actually haven't seen any studies that say, people with these personality traits are more predisposed. Although I'm sure, there are certain personality disorders, like maybe narcissistic, that would fall into that. And if you guys want to see it in action, actually, it's just like watch Donald Trump's Twitter. Or read some news about the inauguration crowd size. Like, what a great example of national gaslighting. And actually, so many people, many Republicans now, when they look at the photos, and I don't know if you guys have seen them, like, it's pretty clear. Not that I'm really in the tank for the Democrats, which obviously I am, but it's really clear that Trump had less people than Obama. But I think 30% of his supporters are actually like, no, the crowds were much bigger. Even when looking at the photos, they'll say that. So sorry, I've derailed this into a discussion about my favorite hobby, American politics. Great. what she meant was, so the question was, what do you recommend for women when they're interrupted or a guy takes over and says what she meant was, which is delicious. Thank you for that example. Yeah, so, I mean, women are supposed to be nice, right? We're not supposed to offend other people. So depending on how badly you want to shake things up, one thing you could do is just get all fired up about it and be like, hey, I was talking. Depending on your relationship with people, you know, you can do that or not do that depending on how it shakes out. But a softer approach is just kind of wait and then say, okay, great. Getting back to what I was saying, or no, actually, that wasn't really what I meant, although thanks for explaining to me how you see it. Here's what I'd say. And then just wait for them to be done, take it over, and move on. Does that help? Great. Yes?
So for those of us in the room who are managers, obviously outside of the meeting context, we want to be able to promote a culture which supports women's voices being heard, and in which people try to correct the kind of thing you're talking about.
Yeah.
Do you have one or two suggestions for how we can promote that kind of culture outside of the meeting context?
Outside of the meeting context. I mean, I think, so speaking from my own personal experience, this has happened to me many times in meetings and not in meetings at work. You know, I recall quite strongly a whole team of people actually coming to get angry at me for a report I had done, reconciling how we had done our work in the past couple months. They felt it made them look badly, despite all of us not doing an amazing job and the results showing that. And you know, so I was effectively accosted and held hostage in this little impromptu meeting where they said, like, everything you know is wrong, Holly. Isn't that wonderful? It was a cool day. I, you know, cried a lot. And so, you know, in that situation, like, that became something I took to my supervisor and said, like, look, here's what's going on. There's massive discontent in the team. You at least need to know about it. And also, P.S., I'd love some help because this sucks, right? So take those concerns seriously. And, you know, I think a common way for supervisors to manage is to go, well, you know, 4 out of 5 people on the team don't see this as a problem, so it's probably just you. And there's validity to that approach in some cases, but watch for patterns, right? Because like I said, this is a pattern-related thing. It happens over time. So pay attention and make sure that that you let the person who has the non-majority opinion be heard. I think it was it Nell yesterday? Someone yesterday, maybe it was you, said, you know, that, oh God, what was it? Now I've started on it, I can't remember, but they basically said, you have it?
No, I'm wondering what I said.
Oh. Oh no, I'm so sorry. So someone basically said, it was in a breakout, sorry Nell. False alarm. Someone said that people don't get upset when their ideas aren't implemented, they get upset when their ideas aren't heard, right? So make sure that everybody's ideas are heard, and try to, you know, in a meeting and a non-meeting context, try to foster those ideas, especially when you have quiet people on your team. They might be quiet because they're shy, but they might be quiet because historically nobody listens to them. So listen carefully and with a lot of curiosity. Okay?
Somewhat similar to Chris's question about management, if I'm not in the meetings where things are happening, but maybe there are things happening, how might I be able to recognize the symptoms better?
So I'll ask you a question. Do you know about them? Or are you like, there's some mystery gaslighting going on and I want to...
I had some active gaslighting and we fired someone not too long ago.
That's a great response.
Which I found out and then he was gone. But it turned out it had been going on for like 7 months and we didn't know.
Right.
But so I would have loved to recognize or had anyone else recognize earlier. So just more things to look for.
Yeah. So I mean, you could have a conversation with your team about this specifically, and especially given that it happened, it sounds like not too long ago, just say like, hey, you know, we had to let that guy go, and I went to this super amazing talk with this really cool girl about gaslighting, and you know, it came to my attention that I really want to make sure that doesn't happen again. So team, here's what you might look out for, and I want you to know that if this is happening to you, I want to hear about it. And then again, listen carefully and curiously to people who bring that to your attention. But yeah, build the awareness and look out yourself. Like drop in on meetings, drop in on one-on-ones, keep your ears open, and and intervene and make sure that people have a chance to be heard. Yeah.
You said dropping in one-on-ones. One of so you have one-on-ones with your manager, you have one-on-ones with your skip level.
Yeah.
Do you have any advice for when that keeps going up?
When what keeps going up?
The effects of gaslighting keep going up. I don't know.
Oh, so when you're being gaslit at multiple levels of the organization? So the quick plan for dealing with gaslighters, people who have to deal with them, step one is just kind of mention that it's happening and see if that will work, right? So step one is say like, I feel like you're really not hearing my opinion, and I get that that's how you see it, but here's my opinion, and I'd really like you to hear that, right? So you can say that in a kind of non-confrontational way. With most of us who are not manipulative, awful people, that will probably work. It might need some reminding, but it'll probably be okay. If that doesn't pan out, level 2 is to start setting boundaries. And if you're doing this with somebody at your level, basically, how many of you guys know about boundary setting? I might be jargony here. Okay, so boundary setting is when you basically decide for yourself what you're willing to put up with, and then tell somebody that thing, and then act on it. So I might say, Steve, I'm happy to have conversations with you about our technical work, but when you get to that point where you start belittling my ideas and opinions and saying that they just don't matter, that's crossing a line for me. And so if that continues, then I'll just leave the conversation. Then, the next time he does it and every time thereafter, you have to leave the conversation. You can't just make the empty threat. If you're going to do that, though, you're going to put a limit on how you guys interact as a team. So you really need to let your supervisor know, and I would contend also HR, as well as taking notes. Not only to help yourself if you end up in front of HR as a difficult employee, for example, who won't finish conversations with Steve, but also because sometimes HR management will be able to case to let somebody go, and that will help them do it. And so you'll be like saving yourself and everybody from this person. And then step 3, which it sounds like is more sort of where you're at, because if it's at multiple levels of the organization, what are you really going to do? Go talk to the CEO and hope he takes your side? Maybe in a small company, but if you work for like ExxonMobil or Microsoft or something, it's going to be a little tough. So step 3, honestly, leave. Like nothing, to me, very little in life is worth this kind of price. The effects of gaslighting, if it's gotten really bad at work, can be pretty far-reaching. I've seen it take people like a year to recover from this kind of things, and sometimes even longer. So my advice, straight up, in that situation, go find another job.
Just to clarify, that's not happening to me.
So everybody knows, he's okay. Whoever employs him, he's not bailing, don't worry. Back there, and this will be the last one.
So the effects of gaslighting are very serious, emotionally and psychologically. How can you, as a person who's been pre-exposed to gaslighting, when you go into a new workplace, how can you gain confidence and strength to overcome those things that happen so that you can be the person that you want to be in your career path?
That's a great question. So he basically said, if you are one of those people who are predisposed to gaslighting, what can you do to help build your confidence and build yourself up so that this doesn't happen to you at work all the time, and so that you can have the kind of career that you want? So it's a really great question. For me, part of the answer, and look, that I come from that camp, so I'll speak to it personally. For me, part of the answer is do quite a bit of intensive self-work, especially if that happened to you from a young age. There's a lot to unpack there usually. So do some self-work, get in a room with a therapist or a coach or somebody that can be a mirror to you. And on that same note of finding mirrors, develop allies both at work and outside of work. People who will go like, no, that is nutty. Like what's happening to you doesn't make sense, and you don't deserve that. And then I would say as well, implement as a practice, even if it's tough to believe in, implement as a practice those 3 things that I talked about, where you actually actively stand up for yourself. Because one of the most harmful things about doubting yourself is watching you allow yourself to get hurt and being complicit in that. So faking it till you make it in that area, I think, is a great start. Okay, guys, thank you. I'm going to let someone else take the stage.
Wow. That was a really cool talk from a really awesome woman. Thank you so much, Holly. Lots to think about there as we go about our day. Next up then, it's time for a brief message from our gold sponsors, the other half of our gold sponsors. So could those representatives today that are speaking please come down? And we'll get a quick minute from each of them to talk about whatever they like. Come on up.
Hey, thank you. My name is Jared Leviton, and I'm a sponsor. I'm with a company called TriNimbus. I'm the CEO, and what we do is we help organizations with AWS. We're the leading AWS partner in Canada. We work very closely with them. We do pretty much everything from architecture to implementation, specifically a lot of DevOps. We build Kubernetes platforms, really world-class team, and we work very closely with teams in an agile methodology. So if you're looking for a way to speed up or accelerate your projects, we can come help you do that. We can help you manage them 24/7, and we can really work and make you super successful. So if you need help on AWS, TriNimbus is the place to come, and we're hiring people. The team is growing very rapidly. We have offices in Vancouver, Toronto, and Eastern Europe. So thank you.
I realized I missed my announcement of who our other gold sponsors are, if I could sneak that in. So we have Boeing AeroInfo, Demonware, VictorOps, TriNimbus, and Sumo Logic. So sorry about that.
Everyone, I'm Dan Reichert from Sumo Logic. We are a machine data analytics tool that's fully hosted in the cloud. Basically, we take your logs, centralize them, metrics as well, help you analyze, visualize, alert on them. So if you're looking into logging, you're logging right now, wondering what you could do with it, go ahead and stop by our booth, talk to us about it, and if you also want to win an awesome JBL speaker, go ahead and put your name in there as well. Thank you.
Good morning, everyone. I'm Josh from VictorOps, and I'm not going to take too much of your time today. We basically handle on-call and incident management, so if this sounds like something you're interested in, if you're currently on call or know someone who is, come talk to us at the booth right outside. Also giving away a pair of headphones, so please enter to win. Thanks.
I bet if we said, are you on call or know someone who is? Hands up, probably, yeah.
Hi, Hugo from Demonware. We do online services for multiplayer games. So if you've played Call of Duty, Skylanders, Guitar Hero, whatever, you've used our services. So we're proud to be sponsoring for the 4th year, and happy to be here. We're at a booth outside if you want to talk about what we do and kind of those services, and just in general, feel free to stop by for a chat. Cheers.
Alrighty, so now is a lovely time. We are going to take our 10-minute break. Before you go again, I will mention that coming up just before lunch, we will do our open space proposal pitches again. So now is an excellent time to think about those ideas you didn't get out yesterday, or maybe someone here today who's already started speaking has inspired you. Thank you, and we'll reconvene at around 10:30. Welcome back, everyone. Woo! Coffee! There you go. There it is. Thank you. So next up in our speaker line is David Aldurian. He's visiting us from San Francisco. I did it again, from Atlanta. And he is here to talk about machine actionable intelligence and some of the implementations he's worked on at Salesforce. Come on up, David.
Good morning. I have my peanut gallery here, so this should be fun. My name is David Aldurian. Yes, that does sound like one of the moons from Star Wars. No, it is not spelled the same, nor does it pronounce the same. this is how you can find me. I am not on Twitter. I am not on Facebook. I am not antisocial. I just don't participate in those. So it may make it a little bit more difficult for you to get in contact with me, but I'm always happy to answer questions, help out, what have you. A little bit about me. That is not my plane, but I wish it were. I have been working on the Watchdog project for about a year. We started from the infancy, designed it from the ground up, and made it possible to send signals from production. And I'm a full stack engineer. I love automation. I've been called the captain of automation for the team now that I'm on, something like that. So, Chief Automation Officer. That does sound a little bit better, but maybe a little pretentious. So, I'm going to leave this up here for just a second so that the cameras can capture it and people have the opportunity to read it. It is the standard Salesforce boilerplate. I am not going to go through it, but basically what you should get from this is don't buy our stock based on what I say today. Don't buy our stock based on any kind of information you might glean from this presentation. Buy our stock based on what you learn from the public. And with that, I'd like to take you on a little bit of a journey. We're going to start with the infancy of the project. Puppy in a swing, that works for me. We're going to go through our journey through the weeds. We kind of meandered a little bit in the middle, but we managed to pull it off. And finally, the point where we had a triumphant watchdog, actually sending things from production and helping certain members of our production crew do their jobs and deliver capacity more quickly. So the main problem that we needed to solve was simple mathematics. Basically, from a statistical perspective, and you can read about the study and you can learn about average failure rates and MBTFs and all that kind of stuff, hardware sucks. At some level, over the course of a year, if you have 10,000 hosts, if you have 100,000 hosts, you're going to have a hardware failure. Maybe a hard drive, maybe a NIC, maybe a RAM chip. You're going to have an operating system failure because you have to patch those operating systems on a very frequent basis. You have to keep up with PCI requirements. You have to keep up with SOX requirements. You have to make absolutely certain that you are as secure as possible. What do you have to do when you patch a system? Unless you're using K-Splice or one of those other clever solutions, you have to reboot that system. So, math sucks. And growth, from an infrastructure perspective, is a love-hate relationship. I love the fact that my company is growing. Makes our stock higher, makes us better engineers, lets me operate at scale. I hate the fact that our company is growing because it makes me do more work, especially on the on-call schedule, especially in the isolated systems where I'm the only one who can figure out what's going on. We call it GIA. That's a trigger word for some of the people that are in this audience from Salesforce. So the thing I want you to take away from this slide, which I stole wholesale from one of our CEO presentations, is 50 production instances in 2014 and 109 production instances in 2016. And that looks like it's just a little over 100% growth, but the production instances today are bigger than the production instances that we had 2 years ago. So we actually have more on the order of 200% growth and even more than that from a scaling perspective. So the math sucks. I've got all these lights that I got to watch. All these signals coming in, all these microservices that are spread across hundreds of thousands or tens of thousands or whatever scale of hosts that I have, right? And I got to watch them all. Operations is not going to be able to do that. That's too much to do for a person, for a group of people. If I hired 1,000 SREs or whatever they want to call themselves in today's day and age of DevOps, I still wouldn't be able to manage this effectively. Doesn't scale well. And that's why we wanted a self-healing infrastructure. I can't take credit for this idea. It actually came from some of our senior architects in the company. The basic idea was that even if we can't come up with all the fixes that you can imagine, even if we can't program using AI or some conglomeration of nasty if statements and so on, what to do in every event of a failure, we can solve at least 50%. And if we can get to 50%, we can probably get to 80% without too much trouble. And we can eliminate a lot of the intervention work that our operations teams would have to deal with. We just need a machine to be able to do it because, as I think it was Bill said yesterday, machines are really good at doing repetitive things. And most of the failures that we deal with in infrastructure at this scale are repetitive at some level. The problem was we needed to get to the point where a machine could actually take action. We needed to get to the point where somewhere between all the crap we have in, let's say, Nagios or SolarWinds or Sensu or whatever, can actually be acted upon by a real computer. And things had to change in order for that to happen, and that's where our journey begins. We had to define certain things in order to move forward with the scope of the project. The most important definition on this page behind me is the one on the left, the check. I am a ruthless person when it comes to this. When service owners come to me and say, I want to onboard onto Watchdog, we have a long conversation about the binary nature of these checks. Nagios gives you 4 different states. Sensu gives you, I don't even remember. I saw an implementation of alerting that was at a private company that I can't mention that was actually based on the DEF CON system. Right? So DEF CON 5, everything's fine. DEF CON 4, you might need to look at something, all the way up, right? I don't care. I've never cared. You get 2 signals, and that's all you ever get. Healthy, not healthy. And if you can't come up with a way to say this is healthy or unhealthy, this is critical and requires action, or this is fine and I can move on with my service, then you're not doing it right, at least from the perspective of our Watchdog project. So people had to redefine what they were doing with their alerting purposes. All these Nagios yellow level warnings that we kept seeing had to go away. So what we did was we took these binary checks and we rolled them up in a logical and we turned them into a service. And that was where another definition change came into play, because we had to start thinking of all of these features of our hardware and all of these features of our operating system as single services. The hardware on which I'm running, the HP server, the Dell server, what have you, the operating system I'm running, whether it's Ubuntu server or RHEL or what have you, those are single services. And those services can either be healthy or unhealthy as a combination of all of those little checks that we created. Firmware revisions and operating system patching and all that kind of stuff. Finally, we defined a standard format that a Watchdog would emit. This is a JSON payload. It's a standard stanza. It contains one field in it that is more important than anything else. I mean, all this identification stuff, host ID, service ID, that lets me divide and conquer my data and take action on what is out there in an appropriate fashion. But the end of the day, the most important thing is that Boolean flag that represents whether the service on that host is healthy or unhealthy. And that's part of that JSON payload. After we made the definitions and after we scoped our project, I came up with the agent itself. The agent is all pure Python. It's extensible, it's modular, it's designed to let anyone in the company contribute to the project, either to add individual what we call detectors. So these are things that can run the how of checking firmware versions, checking file existence, checking running processes and stuff like that. And people can also contribute openly to the configuration as well. And I want to get into the configuration a little bit more on the next slide. But the most important bit of the agent, in my perspective, is the fact that it's introspective. Unlike other homegrown solutions that I've actually written in the past, the agent doesn't run every check on every server. I've got 250,000 checks for a live instance, and that number is actually growing. If I ran 250,000 checks on each individual host, instead of aggregated across the live instance, I would maybe just murder that host CPU. And because the agent is introspective and capable of auto-discovering tests from the JSON file that we use for configuration, it does not have that problem. Instead of running 250,000 checks, it runs 5 on one host. And on another host, it's an entirely different set of checks because that host is maybe a database host instead of an application host, and it runs 8 checks. And then the aggregate sum from the instance from production is that 250,000 and growing. We check everything on an interval. Now, the original interval was 1 minute. We decided that that was too many signals. If you ever have the opportunity to implement something like this in your company, I think every minute is too many signals. Just based on our network graphs, what we did instead was we went to 5 minutes. So every 5 minutes, this agent runs all these checks. Now, that's the default. What we also did was we made the modules, the configuration extensible so that you as the service owner, the user, could put in something called a check frequency. And you could make it so that your check, because it's heavy and complicated for network connectivity checking or something like that, could run every day instead of every 5 minutes. So that was interesting. This is the part where I have to give a little bit of a shout out to the peanut gallery. Ben, wave to the audience. So this is what we call the service description object model. I didn't put it up here because I didn't know if Ben was going to be able to attend. It is patent pending, patent pending, patent pending, patent pending. The idea behind the service description object model is I've got all these JSON files that have to be out there. If you remember from this slide, I have a single configuration file that dictates what checks will run on my host, host A, host B, host C. They all have different configuration files. This service description object model generates those JSON configuration files without the need for me to get involved in, writing individual JSON stanzas. Instead, we took simple YAML files that are spread across our entire GitHub instance in our own private network, owned by our service owners, maintained by them, and it's just like 10 lines in a YAML file can describe a service. And that not only describes what the service does, it describes where the service runs in our entire infrastructure, because we can use wildcards and regex patterns and stuff like that. So based on a combination of these YAML files and CMDB information, we can generate thousands and thousands of JSON configuration files from what I think right now is 26 YAML files picked up from multiple GitHub repositories. Works great. We auto-build this. We send it into production on a pathway. It goes into production twice a week, and we guarantee that our configuration is always up to date. The daemon automatically updates its configuration based on a new dropped JSON file. So it's entirely separated. So if I drop a JSON file on the system, in the next 5 minutes when the interval runs, it sees that it's new, clears all of its watchdogs, reloads, and checks again. The hardest part was the sales pitch. I am an infrastructure engineer. I have no clue what your service does, and I never will. If I become a subject matter expert on every single microservice that we run in our company, I will either have an aneurysm or a paranoid breakdown. You can't do that. So instead of becoming the single gateway, instead of becoming the one person or the one team that could actually generate these configuration files and maintain them, we farmed it out. And we had people like the Strata team and people like the Ajna team and people like so on and so on and so on create their own YAML files, maintain them in Git, and feed them to us. If you can't put it in a YAML file, let's pretend for the moment that I hadn't already written a module to check an SSL certificate for its expiration date and its CA pathway, and you needed that functionality, you could write it yourself. as anyone in the company with a Python programming background can do, you can extend the base detector class in my agent. You can make your own detector and submit it in a PR for review. And it only takes about 23 lines of code. This slide right here, I've been rushing just a little bit to get to because there's a lot on it. And I want to talk a little bit about the challenges that we experienced when we tried to sell this to the rest of the company, to our service owners. They didn't understand, to start with, what the difference was between monitoring and health signals. Monitoring, can I just say I hate the company LifeLock, I hate everything that they do, but I love their commercials. The reason that I hate it's never mind. I love the commercials because they have this great statement where the security guard says, "I'm just here to monitor what you're doing. I'm just here to monitor." There's a robbery going on. He turns to the people on the ground. He says, "There's a robbery going on." The same thing happens with monitoring. We're saying something's wrong, but we're not taking action on it. That's what we had to explain to our service owners. We wanted to take action. We didn't just want to say warning, critical, so on and so forth, little dashboards and stuff like that. We wanted to take action. We also needed to express the fact that machines are going to do this job, right? All the information that you would normally get from a log file is going to be in a separate place. It's going to be in a separate place. It's going to be in Splunk. It's going to be in those other places. We're not giving you debugging information. That's not what this is for. Your single check should be clear enough from its definition that it's simple to understand. And we're not giving you any of those messages. If you want to see why a check is failing and you don't understand why the check is failing because you didn't build it yourself, there's a log file. It's in Splunk. It doesn't go to the dashboard. The other thing that we had to make sure happened was prerequisites. It's very important to understand that in order for this to be distributed across our entire environment, we needed an orchestration engine. It didn't have to be Puppet. Puppet was just what we used at the time. It could be SaltStack, it could be Ansible, it could be anything, but what ended up at the end of the day, your machine, your service, all that kind of stuff, it had to be managed through Puppet, or it wasn't going to get our stuff. And a lot of people didn't realize that to start with, and we had to make absolutely certain that they moved to Puppet to meet our requirements, and then we were able to move forward. Containerization is something that I want to come back to near the last slide when I talk about our next steps in the process. But we are telling people that if you want Watchdog as a service to help you fix your problems, to help you actually bring your service back up automatically, then you need to move toward containerization. The Watchdog is in production. We have here our triumphant collie on the rock or what have you. The Watchdog is in production. It's actually sending signals right now. Our current results are coming from around the world, and not only are we processing these JSON payloads that I talked about, these Watchdog signals from the agent itself, 250,000 per instance, right? We're also processing signals from other tools that have been created by other people in our company because we unified on that messaging format, and then we can consume that in a great big swath. So now, not only can I tell you that systems level things like running processes and files and permissions and network connections and so on are healthy, I can also tell you on the dashboard that we created whether or not your application that runs Java is healthy. And it has nothing to do whatsoever with whether the process is running. It has everything to do with the little unit tests that you can write in your own Java code to just run every once in a while and send a JSON payload up to our report collector. So we're able to unify this based on the message format. My biggest problem here and why I put this picture on this slide is that right now, today, people are still involved. The Watchdog is automatically deployed to all of our systems. The configuration is automatically deployed and updated. It all works great. The only thing is, We don't have a machine yet consuming the signals. We have a dashboard that we built temporarily in order for people, happy people, you know, they're happier than they were before for certain, to consume those signals and take action on them. And that's what has made our capacity builds much faster. But that's not the end game. The end game is fly-by-wire. The end game is 4 R's. This is what I was talking about when I talked about containerization. Your service isn't healthy. Process isn't running, file isn't there, what have you. So we restart the service. We use a standardized, Kubernetes control plane or whatever you want to do. We restart the service. Doesn't fix it, okay? So we reconfigure the service. In reconfiguring the service, that may mean redeploying it not through a container. It may mean redeploying the Docker container. It may mean rebuilding the whole thing right there on the system, depending on how your deployment works. That's why we're moving toward containerization, so it's very simple. Instead of reconfigure, it's just reprovision. That doesn't work. Maybe we should try turning it off and turning it back on again. So we reboot the system. And if that doesn't work, we throw a ticket to SRE and we say, you know what, this system isn't working. Rip that puppy out of the rack. Let's put something new in there. Let's get it working again so that we have the capacity. And the reason why this is so important to us is because our systems are resilient, but not infinitely resilient. When a host goes down, our capacity is diminished, and therefore we need to ensure that it comes back up before something else happens. When your backup is dead, fix your backup before your live site goes to crap, right? So we want to be able to take these actions proactively before there's any kind of noticeable problem to our customers, to our service owners, and so on. So we're talking about sending direct alerts to dashboards specifically for that exit case from the 4 Rs, right? Instead of sending it to a custom dashboard, we go through the 4R system first, and then we fire to a custom dashboard that was built by our SRE team, not by us, and it alerts them to the fact that they need to replace a box. And eventually, and this is a big deal in our company right now, health-mediated deployment will be a thing. The watchdog is going to sit there and say, is this system healthy or not? And then health-mediated deployment is going to come in and check that watchdog and say, are you healthy or are you not healthy? If you're not healthy, I'm not going to take any action because I don't want to further complicate a system that is unhealthy. If you're healthy, I'm going to deploy the new version of the application that has been requested by the change case. And then, 5 minutes later, I'm going to ask you, are you healthy? And if you're not healthy after my change, I'm going to automatically roll it back. Health-mediated deployment is still in process, but the watchdog is the first microservice that's going to make it possible for us to do that and do more control plane work across our entire infrastructure. So that's our next steps. And that's all I really had to say. So I have a couple minutes left, and then I guess 5 minutes for questions. Okay.
I appreciate your inclusiveness trying to support JSON and YAML. That's very nice. Thank you.
You're welcome. He said, I appreciate you supporting JSON and YAML. It does seem redundant. I promise you that it's not. You're only going to have to work with YAML. Okay. Questions, comments? Right there. I saw that coming. I want to. Let me put it that way. Well, that part, yes. But that's, yeah. The refocus dashboard is open source. The question was, are you planning on open sourcing this? The answer is I want to. But as of right now, certain aspects of Watchdog contain Salesforce-specific information, proprietary information. Releasing it into the wild would be considered a legal faux pas. And the legal team knows this. So in order to open source it, I would have to remove all of that, and I would have to get the legal team to review it. That second part's the hard part. So I don't see it happening anytime in the very near future. But sure, one day, when I'm all grown up. In the back. The question was, do we have problems with poor quality checks, and how do we deal with that? And the answer is yes. We do have problems with poor quality checks because, like everything else that goes into a computer, it is originally designed by humans. So when a human being makes a YAML file and says, my service contains this process, and they create a process command line pattern that doesn't exist, because they grafted it wrong, then we start sending bad data to the dashboards. And we start complaining about the fact that something doesn't exist and it's not supposed to. The way in which we deal with that right now, aside from unit and integration testing to avoid egregious mistakes, because we can catch the egregious ones, is basically just service ownership. If you tell me that your service contains this process, and I check that process for you and it doesn't exist, who am I going to page? I'm not paging me. I'm paging you. In the back.
Can you perhaps contrast Watchdog and other checks that you use that with system state checks like DOS or
I didn't hear the other product. GOS. Hey, the question was, can you compare and contrast this with other system state checks? I'm not familiar with GOS. I am familiar with Sensu. I would actually argue that there are some similarities between Watchdog and Sensu in the fact that Sensu is extensible and does system-level checks, and anyone with a systems engineering background can create scripts in Sensu in order to check something. I would also argue that they are wildly different in that Watchdog doesn't allow you to write any scripts. In fact, from a security perspective, we explicitly stated that we will never run someone else's executable code, ever. Watchdog will only run whatever code has been PR reviewed and submitted as part of the main source. I've been asked to add side loading, and I have security support to say, no, go redesign your work and make it a real Watchdog detector. That hasn't been exactly popular because people want to run their own code because they've already written it and they don't want to do the work to convert it. But I have vice presidential support, so they're going to do it. I love this question. How do you distinguish between a temporary network outage and an actual machine problem? And the answer to that is actually part of the 4 R's that I was talking about, the fly-by-wire thing. We're writing another service that we're calling the component service, and it's going to sit at the data center level, and it's going to aggregate these signals, and it's going to actually be the one that makes the decision, okay, I've lost a signal from a single machine, right? If I have bad signals from a single machine, that just tells me that something's unhealthy. If I have no signals from a single machine, that tells me the machine is out of service for some reason. And based on the number of machines and their locations in the VLANs and all that kind of stuff, it can actually alert us to those kinds of network outages as opposed to single host issues. So. Did or does? How long did it take to understand Watchdog, and how long did it take to implement it? From an engineering perspective, from a back-end perspective that I'm providing this service to you as a customer, about 9 months, beginning to end, to actually understand it, create it, and get it ready for production purposes. Actually getting service owners to understand what they are onboarding into, and onboarding them slowly as we move through puppetization, containerization, and all the other requirements. It's a little bit slower than I'd like. Could you rephrase the question, because I'm not sure I understood it?
Let's say you have your first deployment of your production server.
Uh-huh.
Would it be able to say, hey,
Ah, okay. Would you be able to create a day zero watchdog? It's there immediately when the server is provisioned. The actual answer to that question is that's what we did. I didn't hit on that, but it's in one of my slides. It's there from cradle to grave. The moment the server actually has its very first Puppet run, which is immediately after provisioning, Watchdog gets installed. And the configuration file is customized for that particular server based on its role in the company because we have cattle and not pets, right? So I immediately start getting telemetry even if the application hasn't been deployed yet. And that actually leads us to the punch list that makes capacity adds faster because I can actually say, this application isn't deployed, this application isn't deployed, this database isn't deployed, and so on. And immediately people know what to do in order to bring it up to production snuff and get it approved by site reliability as part of a production data center. Back in the back.
So in regards to your edge detecting and deciding whether or not it's a hardware problem or just a network glitch, are you going to be using a consensus with that? And if so, would you be using something like graph protocol?
The question was, when we're trying to detect the difference between a simple network outage or a larger host issue or, that sort of thing, are we going to use Raft protocol or some other similar, a consensus build? I'm going to be honest with you. They put me in the weeds and made me make this. The senior architects that I mentioned earlier that came up with the idea of actually self-healing infrastructure, they're working on that separately as a different project, the component service. They standardized the message format so that we wouldn't have to completely collaborate over a 12-month period, 9 to 12-month period, and make sure that everything marched forward in lockstep, because they wanted this program to be something that would easily deploy and maintain and have service ownership. So I don't really think that I can answer your question. In the back, do I have one more? Oh, back there. How do you handle Puppet deployment failures? I could do an entire talk on that by itself. Let me see if I can give you the 30-second speech. Puppet deployment, so Watchdog itself actually has permission to go and look at the last run summary.yaml file on every host and confirm whether errors exist or not. So as long as Puppet runs the first time, Watchdog will check that. Now, if Puppet doesn't run the first time, we have something called a RIAC database that we're able to query and determine immediately if Puppet didn't run on a host. So, but what normally happens is if Puppet didn't run on a host, it's clear. It's ridiculously clear because we have a record of all the build stuff that we did in order to get it to the point where Puppet should run for the very first time. And if it doesn't show up on certain things, then Puppet didn't run. So the answer to how we solve Puppet didn't run, detection is one thing. How we solve is not my favorite. I'll just leave it at that.
Thank you very much, David. So next up, we welcome to the stage Adam Arsenal from Hootsuite to speak to us about their APIs for exploring application service dependency graphs in real time.
We may have a possible AV issue here, so just warning you. But I was planning on doing a demo in real time, but I made a video instead, and so we're having sound issues with that. So I may just have to play the video and talk over it if it doesn't work, but we're trying to get that going. Good to go? Okay. All right, hi, my name's Adam Arsenault. I'm a developer on the mobile platform team at Hootsuite. if you haven't heard of Hootsuite before, we're a social media marketing platform. We currently have 15 million members, and we're used by about 800 of the top Fortune 1000 companies. I'm going to give you another journey today. Seems like a common theme, but I'm going to talk to you a little bit kind of like of our history of our architecture, our road to microservices. I'm going to talk a little bit about the service graph just so we understand kind of what we're talking about there. Then I'm going to give you a demo, hopefully, of a dashboard tool that we've created that allows you to navigate in real-time microservice graphs. And then I'm going to talk about the API that kind of backs that all up. So Hootsuite was founded in 2008, and we were a giant PHP monolith. And we still are pretty much a giant PHP monolith with microservices underneath it. That's our main product. We have other products which we are combining microservices in sort of a more modern architecture, but we still, like our main product, has PHP layers, and underneath that, lots of microservices. In about 2013, we decided we would try and actually start using microservices. So at the same time, we were experiencing hypergrowth and continuous integration. We were like playing with continuous integration in a pipeline, deploying our main product, and we were trying to add many moving pieces under the covers at the same time, which caused like lots of problems. Today we have about 30 plus services in production, and things are a little bit more smooth, but we're not perfect. At about the same time, our CTO was really kind of obsessed about Conway's Law. Not sure if you guys are aware of it, but really it kind of states that system design is kind of like constrained by your organization design. So at the same time, while we're hiring all these new people, as we're changing our tech stack, we're basically splitting up into teams too. So we're going from this like large monolithic team into all of these other teams that are going to be creating services. So you would have many different people trying to work on a tech stack together, right? You might have a JavaScript developer that's writing a UI that is dependent on some service way under the covers. What happens if cascading failures happen? We have integration tests in a pipeline that are running and sometimes failing. Oh, well, why are they failing, right? We have those types of scenarios. And then we have production type scenarios where we actually just, you know, the dashboard or the main product isn't working, we're getting alerts, but it's really unclear what the alerts are because there's just so many going on. So we're seeing lots of like cascading type failures. Again, yeah, like the biggest two scenarios that I can think of are more in the integration environments and just trying to give visibility to people. When you start to create microservices and you start to like actually cobble all of these things together, our experience was that most people don't really understand all the services that are there, right? They don't understand all the moving pieces. So for them to actually go and like write a piece of code and deploy it into production is much harder than it was in a monolith because they can't debug the way they normally were able to, and they can't do sort of the normal workflow things that they wanted to do. So to us, the biggest problem was just visibility in general. We wanted to find a way, like how can we empower everybody on the team to be on an equal foot and just say like, you know, something's gone wrong. How can you yourself go and investigate what's wrong? And how can you learn about the system? And how can you empower yourself and your team? So really, our biggest problem was just the visibility and the fact that our architecture is changing all the time. That's one of the awesome things about microservices is that it can just change every day, right? People can push new services, but it's also really hard to understand. So let's just talk about the service graph kind of just in general right now so that we all kind of can understand where we're going with the rest of this journey. So we got a monolith, right? It's really a service graph with just one node. Generally, when like in our journey, we took this monolith and we started breaking it up. So we took common components like member or in our case, organization, and we started breaking those up into services, right? But that's used a lot in your monolith. So generally, you kind of start with something like this. You start simple, you break out a couple services. That's pretty easy to understand, right? There's only one or two more things that you need to know about. Then you add more. And generally, like, I think it's kind of common that most people, when they're breaking out from a monolith, will kind of have one layer of services, not really very many interdependencies yet. But the real confusion comes when you start to do stuff like this. You have a whole bunch of interdependencies and services. And now services health is not just like itself, right? Like it's actually dependent on other things. It can't do its job properly if other services aren't doing their job. And understanding that can get way more complicated, especially when you start going. That's 7 services, right? We're saying 30, right? Like when you get to 30 in production, we're not Netflix, we're not Salesforce, but that's still a lot. It's still hard to understand. So what happens when Service 2 here has a problem, right? It's great. Service 2 is having a problem, but it really means this is the issue, right? We have a bigger problem than just Service 2. And so how do we go to enable other people that don't necessarily know that Service 2 even exists? How do we enable them to understand that their test might be failing because of that problem? That's kind of what we were trying to tackle. This diagram here is an anonymized version of our services. So this is a document that's generated from the API. We actually do this daily. I'll talk a little bit more about that later. So right now I'd like to try and do the demo. Let's see if this works.
Let's debug a failure.
Oh, that's too far in.
Looking at a dashboard for a demo app.
Yeah, he's getting it up there.
That I created called the Skateboard Store.
Can we go back just a little bit?
The Skateboard Store is a web application that is...
Okay, cool. Thanks. Low tech, but great solution.
Let's demo the Voltron app. Right now, we're looking at a dashboard for a demo app that I created called the Skateboard Store. The Skateboard Store is a web application that is made up of many microservices. I'm going to go over the UI of the Voltron app itself before we start exploring so we know what we're looking at. The top left, we have a set of breadcrumbs, and the breadcrumbs will show us the path that we've taken as we're traversing the service graph. Below that, we have a metadata section, which shows us things like the name of the node that we're looking at, a description, the owners or maintainers, and some links to documentation, code, logs, and statistics. All of these things can be helpful when you're browsing around, exploring, or trying to debug something. Below that, you have a set of internal dependencies and service dependencies. Internal dependencies are dependencies that this node in the graph owns, and service dependencies are the actual microservices. If we look at each item in the service dependency list, we can see that all of them right now have this little graph icon on the right. The graph icon means that you can actually click on that and navigate or traverse to the next level of the service graph. So if we look up here at the breadcrumbs, we can see that we navigated from localhost 8080, which is the actual demo app itself, to the member service. So let's go back to the Skateboard Store demo app. The last thing that I want to point out is the top bar here. Now this is a history list. If you click on them, you can expand them and see more details. Green means good, so that means that a successful status check was run on the server. Red means that some sort of error happened. And if we look here, we can actually see that it looks like member service wasn't running because we got a connection refused error. You can also see yellow items up here, which are warnings. One thing that I want to point out about the Voltron app itself is it does a heartbeat of the service graph every time you see it flicker. So if we watch here, it'll flash here in a second. There. So that was the back end of the Voltron app actually doing a health check and traversing all of the different nodes in the service graph to come back and paint this picture for you. Let's explore the Skateboard Store app using Voltron. Right now we're looking at the top level Skateboard Store app. As we can see on the left hand side, we have one internal dependency, which is Memcache, and we have a list of service dependencies, which are our microservices. Let's try navigating into the member service and see what it's made of. So member service looks like it has one internal dependency, which is a member database that is a MySQL database. And it doesn't look like it has any service dependencies. Let's navigate back to the top. We're at a leaf node there. So the next one is a product catalog service. Let's check that out. So the product catalog service has a database as well. And this time it looks like it's a Mongo database. Looking on the right, it doesn't look like we have any service dependencies either, so we're at a leaf node again. Let's go back up to the top. Next, we have the purchase service. So the purchase service is a little bit more interesting. It has two internal dependencies. One, a circuit breaker to PayPal. And the second being a database, which is a MySQL database for purchases. Let's go back up to the top. The next one is the reviews and rating service. So the reviews and rating service looks like it also has two internal dependencies. This time it looks like the developers have chosen to break this up into having two databases rather than just one. A ratings database, which is MySQL, and a reviews database, which is also MySQL. Let's go back to the top because we're at a leaf node again. Lastly, we have the shopping cart service. Let's see what it has. So the shopping cart service has an internal dependency of an Aurora database, and it also has a service dependency on the product catalog service. That kind of makes sense. A shopping cart would probably need to know about products. So let's navigate into that. So now we've done a second level traversal in the graph. And we've ended up at the product catalog service, which is a leaf node again. So we can go back up and back up to the top. Let's debug a failure. So to simulate a failure, I've actually stopped the product catalog service. This will create a cascading failure because the product catalog service is actually used by the shopping cart service as well. If we look along the top, it looks like this has been happening for a little bit because we have some history that's showing red. So let's click on a couple just to see that we have the same issue. Yeah, it looks like here we're seeing that the product catalog service is getting an error because we're getting connection refused. And the shopping cart service is failing because the product catalog service is failing. Also because of connection refused. So let's just look at a couple more of these up here to make sure they're the same. Looks like it. And if we look down below, we can actually see the same thing in the service dependencies. So let's click into the product catalog service to see what's up. So the product catalog service dashboard doesn't even render because we can't actually connect to the service itself. So it looks like there is something up there. Let's just go and see the shopping cart service though, to see what's up there. So the shopping cart service is showing a failure, but its DB looks healthy. It's green. And if we look in the right, it looks like it's because the product catalog service is not healthy. Looks like it's getting connection refused as well there. Just for fun, let's try and navigate in. And again, we get this connection refused. We can't connect to the service. So let's navigate back up to the top. And I'm going to restart the product catalog service. And then we should see this become healthy again. There you go. The skateboard store is healthy and back to normal. And it's quite nice because we actually do have the status or the health history up here. So we can go and after we've fixed our issue, we can go back and look at a timeline so we can see when the item started and when it failed or finished. And maybe we'll take the very first successful health check again. So we get a nice timeline of how long the service was down for. It looks here like we were down from about for about 3 minutes.
Okay, cool. Thanks, guys. All right, thanks for dealing with that demo. Yeah, so the Voltron, the idea of the Voltron tool. Hello? Okay, yeah, the idea of the Voltron tool is it just makes it easy for everybody to explore and kind of just check out a service graph in real time and look at the health as well. So I'll just go over a quick how we built it. So the technology is on the front end, we got React and we're using WebSockets. And then at the back end, we have Play and Akka. We are using a single app with a status polling actor, so you're actually only getting one sort of polling action going through your graph at a time. And like the previous presentation, you can set it at any sort of like interval you want. I had it at 10 seconds there just for the demo, so you could just kind of see it kind of going faster. And then we spin up an actor in the back end for every single one of the WebSockets, which keeps state compared to the browser, so we can like push state around as the user's moving around. We can subscribe to different paths in the graph. The status poller will then start polling on that and start giving you history. And yeah, the one thing that's nice about the actors is the WebSockets is everybody is in sync. So if you have like 5 or 6 people that are all trying to debug an issue, they'll all be seeing the exact same view at the exact same time. All the reloads will be happening exactly the same to all the consumers. So how do we build this? We decided that we would take a little bit of a different approach, and we wanted to, since we were just trying to solve a microservice problem, we would solve it at the API layer. So what we did is we went and we created a standard API that every microservice would implement, and then we would create a framework so people would really just have to go and kind of like write a check or use a whole bunch of checks that we have in a single repository and just configure it. So it's really kind of like a declarative framework that people use when their service boots up, and then it kind of can answer all these questions. So we talked about the dependency stuff a little bit there, but we really just have 2 types, internal and service, or external we call it. So these are the actual endpoints. So we have an endpoint that tells us about the service, and this kind of is done through introspection, so it will look at all of the status endpoints that you build or configure for your service, and it will return the state of all of those, and then a whole bunch of metadata. Some required fields, but then also we allow you to extend it with a custom data element, so you can actually pass back anything you want. So if you have specific data that you want to see, you can do that. For every status endpoint that you actually register, you also get your own status endpoint. So depending on how you want to monitor this, you can monitor it directly using each one. So the examples over there, we have a service called core service and a database on a service. So those would be exposed dynamically in the status routes. We also have a similar idea as last presentation where we have an aggregate status. And the aggregate status will basically check everything in parallel and then return you an OK, a warning, or a crit. But we also allow you to filter it. So you can do things like you can go and say, I only want to know about the internal dependencies. So am I actually healthy, or am I seeing cascading failures? So then you can say, are my external dependencies healthy? And you can do sort of like smart things there and look to see if you're actually healthy just yourself, if you're seeing cascading failures, or you can just get the whole answer. So you can say like, I just want to see everything, am I okay? So you can kind of make different decisions there. We don't really like actually, with this API, make any sort of assumptions about monitoring. We allow you to kind of like make your own monitoring decisions as you like. But we do say that, you know, for simplicity, it's nice to just use aggregate, because then you don't need to change checks in the future, right? You just basically say, okay, well, watch this endpoint, you know, alert me if it's ever wrong. And the output of this should tell you the check that failed and then the error. So this is kind of the magic of the dashboard. We have an endpoint there called traverse, and it will take in a list of service IDs and allow you to start at an entry point. So when we were looking at the demo, we were really like looking at the app, right? And then we were kind of going different levels deep into the app. And we actually just doing that through like a REST endpoint. So we can pass the IDs of the services, and because every service implements this interface, we can then traverse the graph. And you just basically take the IDs off as you're going down. You get down to the end of the traversal, and then you can execute an action. So you can do something. So right now, we just have it that you can do this about endpoint. So we just basically are like saying, okay, you check everything that you have, give me the metadata that you have about yourself, and then we'll expose that at the top layer. And so the Voltron app is really just kind of displaying the result of the traverse, and you're giving it the parameters to traverse. The kind of the cool thing that I like about it is in order to monitor a whole application, you really only need to monitor the top level. So like, we don't actually alert or have our alerts at that level, but from a developer's point of view, it's nice, right? They're like, well, I was trying to work on this application, so I can go and look at it from my point of view. One of the other things that I also think that's important about this is it tests the network pipeline, security groups, load balancers, and everything that your actual application does. So you're not sitting on a host and monitoring that, right? You're actually saying, well, if I was a user, would this work? Yeah, so I'll just go over some brief usage here. So again, we don't really say how you monitor. You can use this, you can use the tool, but obviously that's not going to send you alerts. So in practice, we actually use Sensu, and we use the same sort of endpoints locally to monitor the service. And by default, we try to get people to use aggregate. But if their service gets too complicated, and we have some really complicated services with lots of checks, and things that depend on things that we don't even control that are externally. In those examples, we may want to break down the checks and have different sort of intervals and whatnot on each check and different thresholds. Again, like we saw, you can debug with this, right? So we actually have some widgets that show the overall status of apps, and we can put them in deployment pipelines. So you can see like, oh, the test failed on this run. Oh, was the environment actually okay? So you can go and look at that, and you can kind of like judge, was that a valid test run or not? Should we fix the services and then maybe run the integration tests again? That's kind of something that we do. Also, this is useful. So we have a version of Voltron hosted internally in the dev environment, and the app itself just takes URLs or IPs and basically assumes HTTP. So you can spin up a local service, configure all your status endpoints, and then point a local version of Voltron at your service just to make sure it's working. So that's kind of a nice way to kind of like debug before it goes into staging or production. And again, the explore and learn. This is pretty valuable for new employees that are coming into a really complicated set of microservices and really have no idea what's going on. And document. Let's see if this works. It's not a video, it's just a GIF. But like I showed you that one version before, we actually check our UML. So this is generated by UML, and we actually check this into Git every night, and we publish it to Confluence. So every day, as our service graph is changing, we're documenting our service graph and letting everybody else know in the organization what's there. All of these different polls also have all that metadata that's there. So if you have log links, stat links, dashboards, all of that stuff can be generated and put into Confluence or other types of places for documentation. We're still not doing, like we could get better about this, we're still not generating API docs and doing that kind of stuff. That's still all a manual process. But at least we're documenting this in a way that's like growing like our application is, which I think is a big win. Well, I think that's the last slide anyways. Let me just double check. Yeah, and then open source. So we have started open sourcing this. We've open sourced the API documentation itself. So if you wanted to go and have a language or a framework that implemented this, you could do that. We've open sourced 2 frameworks for Go. So the demo that I showed you was all Go microservices working together. And so we have one for the net HTTP library and one for the Gin framework. So those are both open source now. And we're working on getting the tool kind of open source. So similar stuff, we need to kind of pull out some proprietary information and think of the best way to kind of move that forward. But our goal is to share that with the community. We also have Scala version and a PHP version, which we haven't kind of got there yet. And I guess one of the other things that I'd like to say about it is that because we just defined the lowest barrier to entry as implementing the API, it doesn't matter what language you do it in, it doesn't matter what sort of microservice framework you use, you just need to implement this API. Cool, thank you. Looks like we got some questions back there. Yeah? Yeah, totally. Good question. I mean, it's the same for status endpoints, right? Like, if you're doing anything that's exposing status about microservices in your service, you're not going to put that into production, right? So we block those endpoints. Yeah. Yeah, back here. Yeah, so that's the declarative part. So the declarative part is we give you a framework which allows you to say, I would like a status endpoint for this status check. And so we have base things like if you want to check an HTTP service, we already have a status check to do that, right? So it's pretty declarative. You don't really need to write a lot of code. But you do things like say, I want it to appear at this route, and this is kind of some information about it. But you don't really need to write it like that much code to do that. And then the introspection part is really the crawling part, right? So when you saw that, that diagram that showed kind of all the nodes and whatnot, once you have your service implementing the API, you can do lots of cool things. You've got an API there. You could write tools that do many different things. You could write a tool that goes and checks to make sure all of the nodes have the right version after a deploy. You could do things like, I don't know, I don't have all the answers, but like for us, the biggest win was just the visibility. No. No, it's not doing that. Yep. Yep. Yeah, so the question is, have we experimented with using more of like a graph visualization in the tool? We have a little bit, and we just haven't gotten to a really great solution there. We found that mostly for most teams, they really want to see their service. So kind of drilling into the dashboard is, I think, our first step. But I think that's a good, it's definitely on our nice to have list, is to be able to have a nice live updating graph view. Any other questions? Oh, yeah, down here?
More of a comment, but I really like the about page. Normally that sort of stuff is hidden in the repos. You find what it is, you go look it up, find the person. Having it all there as part of the service is great.
Yeah, and so right now that's a JSON file basically that's kind of either packaged with the service during build time or just a JSON file sitting in there. In the Go implementation, it's just a plain JSON file. But you're right, like I think that for people to have a central place to go and learn about that stuff, that's important. And we tried to put it as close to the code as possible, because I think then you'll probably update it more. Yeah. Yeah, in the back over here. So yeah, so you can, the question is, what's a network partition look like? You can have a network partition where, for example, one node in the service isn't available, so one worker. Or you could have a network partition where all of, like, one path to the service is not available. So, like in the skateboard store example, we showed one sort of like cascading failure, right? A network partition would generally show up as some sort of flickering. So if it was going there, and depending on like how, it's either the service isn't there, so it's timing out, and you can't get to it at all. So it's kind of like the connection refused example there. Or it's maybe a subset of the whole service that's having a network partition. And then in that scenario, your load balancer, if it hasn't taken out of the pool yet, you would actually just see some flickering. So it would be an intermittent failure, much like your customer would be seeing, right? You'd see certain things going through and certain things not going through. And those are generally hard to find and fix. Yeah. Yeah, another question? Not yet. So we kind of, we do our alerting through Sensu, and we use the checks, but it's not tied directly. It would be nice to experiment with sort of doing some stuff similar to the last presentation, where we could like, monitor in one place, kind of make some decisions if certain things are going down, and then alert on things. But we haven't gotten that far yet. We've kind of, we're not there. Oh, down here? We have had circular dependencies, and you would think that probably wouldn't happen. But so in that, we generally find them. Like, this is actually a good tool in helping you find these weird circular dependencies that you don't really know that you had. And what we would do in those scenarios is we would manually set it to not traversable. So it would show up on the right side as external, but the API wouldn't actually traverse it. So you wouldn't, in a health check scenario, you wouldn't actually keep going through it. We change, so when you implement a status endpoint, you have to implement 2 checks if you would like something to be traversable. So you implement the check, the aggregate check that says, if I look down one layer, are you healthy? That's called the aggregate check. And then we also make you implement the traversal check. And so if you don't implement the traversal check, you can't traverse. So you can still get the healthy part of it, but you won't actually cause a cycle. Yeah, I'm here. Yeah, we definitely had issues. So the question was, do we have any adoption issues? Because when we actually launched this tool, we had about like 15 microservices maybe in production already, and none of them implemented the interface because it was brand new. So the one thankful thing is that all of those services were actually running in the same framework, so we were able to kind of bootstrap the framework and get it going. There have been other challenges of people not knowing that it's there and maybe not filling it out. So that's kind of one thing. And then other challenges would be when we add new frameworks or we use new languages, we then have to kind of build that base again, right? But once you build the base and you get it there, we're kind of, I think, at a point now where the API is stable. We're not making a lot of changes to it anymore, and it's working pretty good. So we have Go services using it, and we have Scala services using it, and we have our PHP monolith using it as well. Yeah?
Have you considered doing something where the rollout is dependent on the traversal or the testing, such that if you forget to describe your dependencies, you fail very early in the pipeline, you won't even be put into product?
Could do. Yeah, it's definitely an idea. We again, we've kind of kept all of this stuff separate. We don't necessarily make it so that you have to do that. You don't have to be part of the graph. If you want to go in there and you want to cowboy your stuff up and you want to put it in there, you don't need to be there, right? That's one of the kind of values of Hootsuite is the autonomy. So we set best practices. We want people to follow them. And we try and get them to follow them, but sometimes that doesn't happen, right? And so each team, again, is a little bit different, does things a little bit different. I guess another example would be if we make an acquisition and we bring in a new company that might have services and stuff like that. They're obviously not going to be doing it, right? So yeah, there's some stuff there. So we would have to basically get them on board and whatnot. Cool. Any more other questions? Yeah, okay, that's time. Thank you. Thanks.
Thank you very much, Adam. I can see some definite uses for that on the "it's not me, it's you" alerting. So, exciting time of day. We're getting close to lunch, but before we do, it is, again, one of my favorite parts of the conference where the community really shines. Open space proposal time. Ooh. There are a few of you that I know for sure have just joined us today, so really quickly I'll just run through how that works. What you will do is line up on the left. We'll have you come up on stage and you'll do a quick two-sentence pitch on why something is exciting or meaningful to you to talk about. What would you like to talk about with the community? And then we'll have you write it on a sticky note. We'll send those back again into C100 on the whiteboard, and over lunch, people will mark a dot on the topic they are interested in discussing. Topics that have a lot of dots will get assigned rooms. We've still got about 8 rooms or so today, so lots of space for topics. Today we have 2 open space sessions later, so we are ready for ideas. For those in the overflow room, I know there's only a few today, those on call, those kind of taking a break. Please do come down with ideas if you have them. And we are ready for pitches. Pitch first, right second.
Hi, my name's Nick. I want to hear what your metrics architecture is like. So I just want to do a show and tell. Maybe each person takes 10 minutes, just whiteboards it, and we talk about it.
Hi, I'm Vince. I would like to talk about how this came up a couple times, how we've built and deployed Puppet, but this is pretty much extensible to Chef and Salt, and not really Ansible, but.
Hi, I'm Nissan, and I want to talk about your on-call culture. Not so much your organization's culture, but yours specifically, how you got burnt out, how you mitigate burning out again, how you empathize and communicate with others so that they empathize with you.
Hi, I'm looking for folks who have taken HashiCorp Console and actually used the health check system and integrated that into their alerting. Now, I've done it for service discovery and this and that, but I'm actually looking at the health check benefits of Console.
Hi, my name's Alex, and I've been spending some time recently abusing MySQL to turn it into a little mini single node Kafka, and I'd like to talk about why that might or might not be a good idea.
I love crowdsourcing bad ideas, or good ideas.
Hey, I'm Jonathan, and I'm just interested in talking maybe about anyone who's had experience converting kind of more complex networking applications, like to Kubernetes or something like that. So that's kind of what I'd be interested in. Thanks.
Hi. Today we talked about service failure detection. And, well, I personally consider that a solved problem. We can get to it, but how about prediction? Can we predict a service failure? Is it possible? Let's talk about it.
I predict someone will get paged.
Hi, my name is Min. I would like to hear your voice about secrets management in a containerized microservices environment. Like, what's your experience and how do you manage all your secrets for Docker services?
Is it still a secret if we tell?
Hi, my name is Stephen. I'd like to talk about the S in CANs, sharing. So whether it's around documentation or some other service that you use. Thanks.
It's hard to make fun of sharing. I love sharing.
Hello. As we all know, automation is central to DevOps. I would like to learn about what people have decided to put in their DevOps pipeline in terms of promotion stages, what controls they decided would be good to automate as opposed to do manually. What are especially the ones where you had the most return on the automation investment that you were able to put in, and how far you were able to take it from dev all the way to production or a little bit before that.
Hi, my name is James. I'm with Vancouver Technology User Group, VanTug, and the YVR-FF, the Vancouver Virtual Reality Film Festival. I want to discuss volunteer opportunities in both of those and how we can bring more events to Vancouver and to the user group community, meetup community as well.
Hi, I'm Mike. We've heard a lot of talk about Sensu today. I, for one, am quite interested in Sensu monitoring, and we're hoping to implement it at our company. So hopefully we can kind of get some chats going on, how people are using it and the cool stuff it can do. Thank you.
Hey everybody, surprise, surprise, I want to talk about gender. So I'd like to do a talk on I'd like to talk about what you guys are doing around retention for women or minorities at your companies. So either what you guys are doing that's great, what you guys are doing that's awful, or the fact that you guys just don't know what the heck is up and are scared. That's all good. Let's talk about it.
Come on up.
Hi, I'd like to talk about training and how do you pass on knowledge to your fellow ops or developers, especially for even basic topics from Git to Chef and to even more complex topics of like programming and all that. So I'll discuss how we do training to our fellow colleagues.
Welcome.
So I might be the odd man out in this, but I want to talk about if anybody here, and I haven't done much, has worked with the Microsoft versions of this, actually dealing with Windows services and dealing with like old .NET Core kind of stuff. They've been moving forward. They're still a lot of ways behind.
Anybody else? Ooh, Bala.
Hello, my name is Bala, and there were a couple of questions asked of me about how do you actually survive at a company for 17 years, or just stay somewhere long enough, I guess. So if anybody's interested in chatting about it, I'm happy to share stories and just sort of talk about it.
Last call. Is that everybody? Ooh.
Hey, I'm Michael, and I think I'd like to talk about, I guess, declarative approaches for autonomous repair strategies and how to build self-healing systems, and drag David along if he wants to.
Alrighty, this looks like we have everybody. It's pretty much time for lunch. Again, voting over lunch. Don't forget to cast your vote. We'll probably wrap that up around 1:15. Cast before then. Lots of veggie meals still. Make sure you get what you need. Have a great lunch. Welcome back from lunch. We are now in our exciting time again of Ignites. Woo! Woo! So we have 5 Ignite talks lined up for you today. I'll quickly remind a few of you newcomers how this works. So as we get everyone up here, each presentation is 5 minutes long. We'll have 20-slide deck that advances every 15 seconds automatically, ready or not. And then in between 15 seconds and the next deck will come up. So today we have Victor Yang, Senior Engineer from Earthcast, Jason Yee, Technical Writer and Evangelist from Datadog, Michael Greenwell, Software Developer from Stat Search Analytics, Amin Yazdani, Director at AY Technologies, and Software Engineer Dmitry Vinnik from Salesforce, ready to hit the stage. Let's get started.
We started. Yeah. I'm Victor Yan. I'm going to talk about event-driven infrastructure, continued delivery in Kubernetes and the ECS. So let's imagine that I work for a cool space company. We have hundreds of satellites, each one of them equipped with high-resolution camera, and it's being able to capture the videos in real time. We run some badass machine learning algorithm to extract objects from the video, and it's running on Kubernetes, as you can see from here. And the most straightforward way I can do the continuous delivery is that I call it all-in-one solution. I do everything in Jenkins or CI here. I do deployment. I do the real like deployment to Kubernetes and a notification in case of a failure or success. The other way is I don't like the first way all-in-one solution. I want to break them apart. How do I do that? I want the event-driven architecture. So Sauce Stack is pretty awesome in my view in terms of it's super lightweight, it's very low latency, and as the history shows, the Dow Jones Industrial Avenger was running on top of that. With a 0MQ, the 0MQ being the really workhorse for SALT events. So the event goes like, first, it does the event, generate event with a Docker image, with this tag and the git commit hash here. And then the SALT master will actually has a reactor to that. Oh, sorry. Yeah. So basically, I think I missed that. So the ECS does in a similar way. So instead of using the event generator, will be done in the CI/CD account, and we will publish a message into the SNS topic, which is going to consume by a Lambda function written in Python Bodo 3, and it's going to register ECS, task definition, and update the ECS services. And this stack basically you have two AWS accounts, one for CI/CD account, the other is for each environment, dev, seed, and production. In this way, you can just keep the minimum IAM policy there, saying publish message to that topic. That's all you need. And you can have one CI for all your environment if you want. You don't need to maintain all the Jenkins like some other implementation you have. So in this way, you basically decouple your deployment logic from your CI. So your CI become mean and lean, right? This is the way I prefer architecturally. Sure, you can do everything in one, which is the first version that came up. So let's come to the benefits. So the system is pretty reactive and asynchronous, and it's pretty natural and intuitive. I can decouple them, as I said earlier. I can keep the code a little clean and mean. And not just deployment, the rollback, the creation and the destroy, and even like environment changes, configuration changes can be treated as event as well, but you do need a really fast event bus. That's why I was suggesting, Sauce Stack, because the 0MQ is lightning fast. Then the same architecture pattern you can pretty much like deploy in Kubernetes and the ECS. As a matter of fact, I was thinking about in the very beginning, the machine learning algorithm will be able to generate that analytic on the IoT devices, and then send it over in the Amazon ECS. And the very last benefits is just like IAM policy being small, very minimum. And the downside is definitely it's more complex to troubleshoot, but you have to integrate all this into your AWS solutions. So sorry, this is my first time doing this. Apparently I need more time. I try hard to keep up. So if you want to see the code, I already get it done on like sample code. You can go to GitHub and check it out. And thank you.
Cool. And we just have to wait for my slides. So I'm Jason. As was mentioned earlier, I'm an evangelist at Datadog. But I go to a lot of these DevOps days, and last year I was at DevOps Days with Nathan Harvey from Chef, and he mentioned talking about coffee over DevOps. He actually flipped that. I thought that's a great idea because everybody loves coffee. Coffee's delicious, has loads of caffeine. In fact, the commonly held origin is that coffee was discovered by a goat herder who noticed his goats were energized after eating coffee. And everybody loves coffee. In particular, Canadians love coffee. Third highest consumption in the world. The average Canadian drinks over 150 liters of coffee every year. It's pretty amazing. Now, when I say there's 3 waves of coffee, well, the first wave of coffee was commodity coffee. Not much different from military rations. You had cans of pre-ground, horrible coffee, and despite what Folgers would have you believe, not the best part of waking up. It really was about drinking something hot rather than something that tasted good. But in 1971, Starbucks came along, and they started what would become the second wave of coffee. See, Starbucks took an Italian approach to coffee. They roast their coffee in a dark Italian style, they make Italian-style drinks, they use Italian words like venti and grande to confuse you. And they also take an Italian approach to coffee culture. So Starbucks aimed to become your third place. Your life would be home and work and Starbucks. You see, your third place is where you find your community. So by placing this value on community, they really placed a value on people. And that's why Starbucks started to offer more benefits to their employees. It also led to the rise of things like fair trade and direct trade. Because when you start placing a value on people, you realize that coffee farmers are people too. And when you realize that coffee farmers are people, you really start to value the things that they value, like the beans. That led to the rise of the third wave of coffee, where we start to roast beans and brew coffee beans to accentuate their native characteristics. And it didn't take long for customers to start caring about coffee beans as well. So you learn that when you have these farmers and you care about them, you care about their coffee beans, you start to try to brew your own coffee in the best ways possible. I mean, how many of you have now started using French press or pour over rather than machine drip? How many of you prefer a coffee from certain parts of the world, right? We start to care about these things, not only because they're delicious, but because we care about the people behind them. So let's talk a little bit about DevOps, the history of DevOps. Well, the first wave of DevOps really was Dev and Ops, right? It's the tradition of silos and throwing things over the wall. Much like coffee farmers selling to commodity traders who sold to people who just put things in tin cans. Now, I argue that we are currently in the second wave of DevOps. The second wave of DevOps is just like coffee, where we realize that people are humans. Dev and Ops are people, we treat each other humanely, we're all on the same team working together. And much like Starbucks, who tried to create community, the second wave of DevOps is largely about community. We're all here at DevOps Days. We have meetup groups, we have Slack channels where we get together and we share information and we try to make our industry better. But I argue that we actually need a third wave of DevOps. And the third wave of DevOps is when we can stop focusing on each other as people and treating each other humanely is just the way we do things. And we can actually start to focus on building better applications and better digital experiences for our customers. Much like how, other slide. So the way that we do this is actually that we need to stop focusing on automation. We've been overly focusing on automation and essentially trying to get self-serve ops for devs, right? And that just changes ops into devs. We want DevOps, not dev-dev. The way that we do this is we start getting involved up front in projects. In the same way that we have baristas and coffee roasters visiting coffee farms to understand the nuances of beans, we really want to start getting it so that we are starting to be involved up front in projects, so we can understand the nuances of code, and we can understand the business motivations behind what's being built. And in that way, we can start to build better infrastructure to better service the applications that are being built. Ultimately, this will affect our customers. They'll never understand the technical underpinnings in the same way that I'll never understand why I love coffee from Indonesia, but not so much from Kenya. But ultimately, I do know that I have a preference, and I know that many of you have coffee preferences as well. And similarly, our customers will have preferences for the digital experiences that we're building. Because if digital experiences are the wave of the future, if they're the way that companies are going to differentiate each other, then third wave DevOps is really how we're going to make our customers, our businesses successful. Thanks.
Hi. So my name is Michael. I work for Stat Search Analytics. We're a local SEO, analytics, and data collection company that services digital agencies and enterprises. And today I'm going to talk to you guys a bit about ELK, also known as Elastic Stack. So this is a data collection and logging framework where you send your logs to Logstash, which collects them together, forwards them over to Elasticsearch where they're stored and indexed, and then it's primarily going to be about Kibana, which is a tool that you can use to query and analyze the data there. And so what I'm going to do is I'm going to do this by going over kind of an example of how we used to work with our logs and how after implementing ELK, we work with our logs today. And so previously, we would have a distributed service that's running on many different servers, and each of those services would be storing its own logs into text files. And then we would encounter, an application issue of some nature. In our case, we're crawling data from external services, and we're doing it millions of times a day. And so we'll get something indicating that, we're seeing more errors than we expect to see at a given time. So the first thing we would do is we would go and we'd look at another tool to kind of figure out what's going on with the queue. And we would look at the number of failures we had, and we would look at kind of at a really high level, what are those failures? But if we needed to get more information about those failures, we'd have to go in and actually go to each server, grep the logs, and pull that data out. And depending on the scripts you had on your own computer and your knowledge, maybe you'd be able to get the answer directly from there. A lot of times what you'd be doing is you'd be taking the data you collected and you'd be compiling it in another tool. So Excel's an example, Tableau's another example. There's lots of tools that you can use to analyze data once you've collected together. But unfortunately, because we're dealing with a system that's operating in real time, that's going all through the evening, going through 3 or 4 different tools, as it was in the previous version of this slide, it takes a lot of time and it slows you down. And if we're running into an issue at 4 p.m. and we want to have a fix up by 6, it's not great. So at a high level, this is what our ELK stack looks like. Now, we're going to send all of our log data directly to Logstash. We actually do it through UDP, but there's lots of ways to do it. It's going to put that data into Elasticsearch and then provide an interface through Kibana that you're able to query it. And it changes our troubleshooting process a lot. So the first thing it does is, because we're now sending JSON packets that have a lot of information in them, it's very easy for us to, at a program level, like add and remove that, and then just go fiddle with the indexing within Kibana directly that changes the Elasticsearch indexing. And that indexing of additional new fields and all the fields that we're logging makes our troubleshooting process really, really fast because it allows us to query much faster. So if we go back to the initial example, it's like, let's say we have the same crawl error rate sort of climbing, and usually in ways that we don't expect. Now what we can do, rather than going into 3 different systems, we can start, look at Kibana and say, okay, well, show me the jobs that are failing. And the things I'm noting here is that we can also run this search with more criteria. So now we can say, show me the things that are failing for certain devices. In this case, it's like a mobile device. And you can easily see the details of the data that you're pulling out. And we can take that same query and we can move right over to visualizing it. So we can put it in a graph. We can show multiple things over time series. And then finally, after you have a visualization, you can take those and you can combine multiple visualizations together to build dashboards. And we have much more complex dashboards of this that show lots of different things about this real-time data collection system that we run. And so the troubleshooting process now looks like this. And so it's like, okay, I got this email, what do I do? So now you can go and you can log into one system, you can look at the dashboard, see what's going on. If there's something that you still don't understand, you can do additional queries. You can create new visualizations for any new queries, and then you can modify the monitoring process in real time or for a short period of time, or share it among the team, because you can just paste a URL into Slack and people will get that. So what the Elk Stack has done for us is it's made our investigations faster. Because of the nature of the service, it's like relatively inexpensive to use for the volume of queries we do, and it's managed. And that's everything. Thank you guys very much.
Good afternoon. How's everybody doing? Awesome. Okay, so my name is Amin. I'm from AY Technology, and I want to talk about estimating slowly. So a couple of best practices for agile companies to slow things down a little bit. You need that. Okay, so projects fail, and there are many reasons that they fail, and the failure could be anything from delivering late to actually going to the garbage. And those failures can add up and can cause companies to fail as a result of each individual failures. We used to do waterfall. It was painful. It was very time-consuming. It was not efficient at all, and it was not good with change. You have to go through everything. You have to go through the whole process to bring any change to the system, and that was not working well. So we started Agile, and we saw, oh, there's so useful. You can do things faster, more efficient. You can get things done in less time, and the speed of things was improving so much. And we enjoy it so much that we try to agile everything. We made agile marketing, we made agile, anything you think about it, we made it agile, and it became the buzzword. And when it became the buzzword, everything was about the speed. So we actually devoted everything in the process to gain more speed and make it faster, develop faster, get things done faster. And along the way, we lost something. And it got us to here. We had no idea what we were doing because we started with how we want to do things. We started projects so fast that we were not caring about what we were doing or why we were doing those things. We want to get things done as fast as possible, and that caused bugs. More bugs means more failures, means more risk to each project, more risk of failure, and each one of those means more risk to our companies that they can fail. So that's why I think we need to slow down. We need to slow down and spend some more time on figuring out why are we doing things that we are doing? Why are we starting this project or that proof of concept? And when we start with what and why we are doing things, that's when we figure out that not everything is worth doing, and then when we understand the projects that we are doing, we can estimate them better, we can estimate them more accurately to reduce the final risk that we are taking with each one of them. And when we estimate things correctly, then we actually get value from that. When you guesstimate, you reduce the value of your work, and then you're going to stop estimating altogether because you're not getting the value. And when you slow down, you're going to see things more clearly. You're going to see the corner cases, and you're going to estimate them into your project before they become bugs that you get at the end of the project. They're going to add more time and cost more money to each company. So I'm going to share 6 helpful tips with you. I know that you probably all know them, but sometimes we forget. Sometimes we forget, and I want to remind us that these are the things that we have to spend time on it. We have to pay attention to them. And the first one, and the most important one, is the definition of done. We all know that we have to have a definition of done for each of the tasks that we are doing, but sometimes we forget. Make sure that you have a definition of done. Make sure the team knows it, and make sure that you enforce them. Estimate for QA as you would for a feature. QA is part of your development. If you don't estimate for that, you're going to end up with a higher risk of failure. And that could be manual testing or could be automated testing, but just estimate them. Small features, like we all know, small features are easier to estimate and easier to get done, but sometimes we don't do that. We as humans are much better than estimating smaller stuff than bigger stuff. And we are, as humans, we are so bad with estimating things accurately in hours, but we are good at comparing things. So start using your user stories, story points, and don't make your story points equal 1 hour or 2 hours or a day. Make it actually something that you can compare with and make your story points like that. Acceptance criteria, it takes time. It's not time wasted. It's actually a very useful time. put that in your user stories, and at the end of it, compare your previous sprints, adjust as you go. The process itself should be agile. You should make your agile process more agile by making the iterative loop and getting the feedback from the system. And that's my information, and thank you.
Hello? It's not a joke, but... I mean, I can start earlier, though. Hello, everyone. My name is Dmitry Vinnik. I'm a senior software engineer at Salesforce, and my talk is titled Companies Which Need DevOps But Not Know It Yet. It's a long title, but the main idea, which I'll highlight closer to the end, will be pretty clear and small. So, before I start going into depth for this talk, I'd like to highlight which companies I'm talking in particular. So, to have some generic category for the entire talk, I have to categorize those companies by the simplest criteria, which I chose to be employees, basically the size of the company. So the small organizations are usually companies which have 50 or fewer employees. The medium size are 50 to 250, and the large organizations are, people say, are above 250 employees. So what it means for DevOps is that in a small organizations, because they tend to be of a startup style organizations, they are usually created post-agile boom, and as a result, they use all these rapid development, rapid deployment methodologies, and that actually means that DevOps are actually used in that, those organizations. For the large companies, because of their scale, they cannot afford having the manual processes doing monitoring, alerting, or metrics analysis. They have to use DevOps, whether it's dedicated people, department, or just processes that are done by someone else. But the medium-sized companies are the ones I'd like to focus on during this talk. Those companies probably being created way before the Agile became a thing, as much as DevOps as well. So they're probably also using the waterfall, and they, because of the scale they're still operating on, they still can afford having the manual people who are actually doing all this alerting, notifications, and the manual monitoring of services done by hand. And I'd like to illustrate it by my own example. Basically, when I was just off the university, I joined the organization doing this health check, which basically meant that I would manually go on every 4 hours to some servers to check their services being up or down, check the disk space, do some very simple manual analysis of the data they have. And what I figured is that I honestly detested that. Doing the manual work like that for a person with a technical background is just mind-blowing. So what I started doing is, the company did not know that they needed DevOps, but they hired me as a health checker. And so basically I started doing, I tried to automate manually the work I try to do. So a small example, I knew Java at the moment, so I wasn't expert in DevOps at all, so I used Java to check the disk space. If it's above some threshold, I send the email to my management. And the management started seeing the benefit in DevOps practices, even though it's done probably wrong using Java and quite plain, but they saw, oh, we can actually monitor our disks and drives and lots of other stuff done automatically, and it increases the frequency of checks, it's more reliable, and actually this is where I was introduced to people making mistakes all the time during those health checks. When they check the service, they usually put the service down. So I was able to convince the management myself that they needed DevOps. And what I'm trying to deliver in this message, in this talk, is that basically it's not the title that should drive you, it's the mindset of DevOps. So I would argue that DevOps is not just the position you get, it's the way of thinking. So regardless of what position you hold, I was a health checker and I still try to automate, still try to go beyond the title that I had. So it still means you're doing what you've been tasked to do, but nobody says how well you can do it. And if you're a developer, an engineer, you can still do things that DevOps do. If you're writing some application, consider to make your API more verbose, log things, make it easier to troubleshoot, make it better logs to the server so they can be tracked. Or as one of my colleagues said, if you write an API connected to the command line so that it can easily be used right away. And especially I think it's not just beneficial for the organizations, it's also beneficial for young people because they can find their own calling, not just by the position they've been hired at, but I tried DevOps, I might have been pursued that after the fact. And I believe that many of you started at some, you've been a developer, you've been a manager, but then you found your real calling as a DevOps. So I would really argue that the companies that don't know that they need a DevOps, but they actually need them, are great positions for you to grow and for you to make those companies grow. So I believe I have 5 more seconds, but thank you everyone for your attention. Thanks.
All right, so now we're going to slow it back down a little bit. We have 2 more amazing speakers lined up. Next up, we have Oriol Martinez-Poo and Solmaz Abapursani, ready to share how Best Buy survives the holiday craze with application performance monitoring. Welcome.
I'll just use the... Hello everyone, I'm Solmaz, Lead Performance Engineer at Best Buy Canada, and here with me is Oriol, our Lead Site Reliability Engineer. So what do we mean by the Holiday Survival Kit? For most of us, the holiday season is just about family gatherings, giving out presents, going into exotic trips, and overall just enjoying the holiday spirit. But if you're one of the many employees here at Best Buy Canada, you most probably be preparing yourself for another trip, a trip of survival and success over the holiday events. So on the e-commerce side, as you can imagine, everybody from QA, development teams, operations, business, marketing, they'll be somehow involved. So today, Oriol and I will go over our experience and our survival kit that helped us be well prepared for the exciting trip last year. Black Friday and Boxing Day are 2 major events for retail companies. With all the incredible deals that we have on our website, we can experience up to 30 times more traffic compared to a normal day. So as you can imagine, these events are extremely critical for our business, and we must ensure a stable site for our customers so that we can keep both our customers and the business happy. In order to handle up to 30 times more traffic in a system that the majority of the applications are served from actual physical hardware in a data center, you need to come up with the right performance strategies to reach your goals. Like any other trip, you need to be fully prepared to enjoy the ride. So for us, we had to start by preparing a perfect load model. After that, we need to prepare a performance environment to run our tests on. Like any other trip, you need to carry the right tools with you. And then finally, you need to run many tests until you can happily reach your destination. How will your customers be interacting with your website? What kind of behavior are you expecting from them? And then overall, what's the expected load model of your system? In order to answer these questions and come up with a comprehensive load model, you need to understand the following items. So first of all, you have to spend some time and analyze your application logs from your previous years. So try to see how many hits per second you're expecting to your different APIs, your AJAX calls, your pages, and whatever that will be hitting your servers. And don't look for just one single data point. Try to look for patterns of data. Depending on what you're testing, you might need 1 hour or 2, or maybe a full day of data to analyze. And then you need to spend some time with your development teams and try to understand how the site functions. Here specifically look for pages that can be heavy on your backend systems, pages that can make multiple backend calls or database calls, or communicating with your third parties. They need to be fully understood so that while you're running your test, you can measure the impact that they can have on your underlying systems. Then maybe talk to your product teams and see if they're expecting any new features that can change the user behavior on your website, and then plan for it accordingly. And finally, understand if you're expecting any business growth. So look into your data analysis tools and look for metrics such as number of unique visitors you'll be expecting, or for our case, number of orders we're expecting, and then plan that in your load model. And then always have some room for buffer, just in case. So now we have our load model. It's time for us to prepare our performance environment. In an ideal world, our performance environment should be a complete replica of our production environment. So to start with, the hardware specs, and then the number of instances per applications that we have, they should be a complete replica in both environments. The network configurations, and then the way that the different components of your applications are communicating to one another should be exactly the same. So things like your load balancers, firewall rules, your switches, hubs, everything that you have should be a complete replica. When you're populating your data, try to use the same data set that you will be using on your production environment and put it in your test environment. If you're expecting any growth in your data, plan for it and then mock that data correctly in your test environment. Any background jobs, synchronization jobs that is running in your production environment should also be running here. And finally, any monitoring or profiling tool that you have in your production environment should also be set in your test environment. So as we mentioned, you need to have the right tools with you. In our case, for the performance testing effort, you need to have a load generating tool that you can use to bombard your applications with heavy load. JMeter, NearLoad, LoadRunner are just a few options out there that you can use. While you're running your tests, you need to obviously be monitoring your systems. You need a centralized location to put out metrics from your applications as servers in there. So metrics like hits per second, average response times, percentile data will also be valuable here. Error rate, and then system health metrics like CPU, memory, I/O, network, whatever that you can find from your multi-layer application should all come into this centralized location for analysis purposes. And then finally, just have a centralized logging system that you can pour all the errors that you're seeing while you're running your test into one centralized location. It will help you to correlate your errors and pinpoint a problem very easily. The Elk Stack or Splunk are just two options out there that you can use. Okay, so we have all the arrangements. We get to the fun part, which is breaking our test environment. Try to create your test scripts by using actual browsers and then record the path that your actual users will follow on your website. In this way, you'll be able to gather all kind of metrics like all kind of header values, cookie values, all the AJAX calls, or whatever that is happening behind the scenes. You'll be able to capture them and put it in your test script. Then you need to parameterize your test scripts by using the data that you extracted from your logs. And depending on what you're testing, you might need tens of thousands of different data to put into your test script. And then finally, you need to put this test script use the load model that you had, put it into your test scripts, come up with a test scenario, and then run your first test. So obviously, the first try won't be perfect. So you need to repeat this cycle a couple of times until you reach a point that you are fully confident that you are emulating real user behavior on that upcoming event. You'll be doing optimizations, you'll be putting it back in your test environment, rerunning, so you might just run like tens of thousands, like 100 different tests until you are happy with your test results. And remember, how similar that your production environment is to your test environment, always run tests on your production environment. You'll be surprised to see the differences when you're running these tests, and find those differences before your actual users find them for you. So the tools that we use for monitoring during our performance testing efforts are also used for capturing and monitoring live data from our users. Oriol will go over the APM solution that we have come up here at Best Buy. Do you want it?
Yeah. Okay. Hello, everyone. I'm going to talk about another trouble that my team and I started like 1 year ago. And to be honest, for us, It was like traveling to a place where we have been before, as we all have previous experiences using monitoring, alerting, different telemetry systems. And it was even like traveling to a place where we have family or close friends living there, as we have already some monitoring tools, some telemetry systems in our environment that are already providing us some information on how our applications behave, what the network topology, how our infrastructure looks like. But this time we wanted to travel to that place in a different way. For sure, we wanted to explore, to go to the most popular places and do the must-do activities. But at the same time, we wanted to explore the off-the-beaten path places. I wanted to make sure that we learn and we understand how diverse local people live and what makes every and each corner unique. So when we started this adventure, we also reflect on what means DevOps culture for us. And DevOps for us is not only about tooling. It's probably more about solutions and customer experience. Who are our customers? What do they believe? Our customers are basically performance teams, they are QA teams, they are IT operations, they are development teams, they are high-performance teams, they are cross-functional Scrum teams that are delivering new stuff, new technologies into our production environment pretty frequently. And they are anxious to learn more and to adopt new technologies, new frameworks, and new technologies, and put them into our environments. So once we understood that, we couldn't just look out there and find a good monitoring tool and deploy it into our environment. And once it's there, just do some training sessions to make sure that our teams, our customers, understand how it works and how they could utilize it in order to achieve what their own challenges. We couldn't do that because we have our own DevOps philosophy. And instead of forcing our customers to adapt to our solutions, we have to make sure that our solutions are all the time able to adapt to our customer needs. And in the end, we know that our customers are traveling and visiting unexpected places all the time. And we have to make sure that we don't want to be in that situation where they are trying to deploy a new technology and we say, yeah, we have to make sure that if our monitoring solution is compatible with that, or if there is a plugin for that, we won't to be there anymore. We have to make sure that our solutions are always compatible with all the technologies, even if that technology doesn't exist yet. So very first step was basically gathering the requirements from our stakeholders. And our stakeholders basically, probably like any other company, they were asking for the ability to collect metrics from data centers from different countries, from cloud services, from third-party applications, and then process those metrics in multiple ways, correlate data, create alerts or dashboard graphs. But what is important for our business, what is important for companies like Best Buy, during our Boxing Day, during our Black Fridays, during the important events of the year, every minute is important. Even every second is crucial for our business. So we have to make sure that our teams are always able to identify and catch issues within seconds. Sometimes, and here is where our applications become decisive. So once we understood who our customers are, what they do believe, what they do need, and what's the mentality, what's the idea behind our philosophy, we just had to write out our packing list with all the items that we need for this journey. So obviously we need tools to be able to collect data from different sources, from different data centers in different countries, cloud services. As we'll be collecting from different locations, we have some standards. We need some tools to be able to transport data into a centralized place. We need to be able to process, we need the tools to be able to process data in real time. For sure, we need a database to be able to store time series metrics, and at the same time, we need our customers, we need the tools to be able to exploit data, to be able to analyze, and to be able to create alerts, dashboards. So once we understood who are all the players here, we just need to orchestrate our solution. And we just need to define what will be the stops in this journey. The first stop is our collector. And here we know that our collector will be the most dynamic part of our framework, as our customers will be adding new sources, new technologies, new frameworks, and we have to find a way all the time, constantly, to be able to collect metrics from different technologies. So there are tons of different lightweight applications, lightweight tools that we could utilize in order to collect metrics from our access logs, applications logs, networking information, or infrastructure. You could use file bits, stop bits, telegraph, collect the stats D. And in the end, it's even good trying to try all of them, trying to compare and see how the applications work for our own challenges and decide what's the best tool for us. And in the end, we'll be doing this pretty frequently. So we want to make sure that even there are a lot of changes in the industry, and there are other new tools, new technologies that we have to be testing, and for sure replacing our current solutions that we are using. And for our global scale telemetry or application performance monitoring system, we also need to collect data from our cloud services. So we have to find the right cloud services to be able to collect metrics from other cloud services. Our database are important here, for sure. We have to find ways to collect metrics from our database. But why not think bigger? Why not try to create some automations in order to run some queries against our database and collect other kind of information that could be important for our business? If we're able to correlate, for example, number of orders per second, number of new users created per second to the metrics and the response time of each and specific API, we'll be able to analyze our environment from different angles. And one thing, in the era of big data, one thing that we have learned is that the more data we are collecting, the more information, the more metrics that we have, the more powerful will be our application, as we'll bring the ability to our customers to decide how and when they want to use this information. And why not collect information from our CDN, from our other monitoring systems or automations that we have in place, like real user monitoring or synthetic monitoring? So once we collect this information, the next step in this journey will be our hub. Our hub, in other words, will be the place where our collectors are putting the data into. And again, we have different tools here, different broker systems that we could use for this purpose. So we could use RabbitMQ, Kafka. There are different applications out there that we could use. And one thing that we like to point out here is that this component will play two different roles here. For sure, will be the obvious one will be our transport layer and our framework, but at the same time will be the buffering layer of our solution. So, and in the end, as we'll be consuming information data from different sources, we have to make sure that we are able to handle fluctuations in data flows. So that's why it's a good strategy to try to separate and create multiple queues, multiple channels for each data source. That way, we also will be able to scale up or scale out our queues. So our Hadoop file system or Spark streaming are pretty good candidates to be able to process data in real time. So again, probably we find other tools out there that we could use, and the technology is important, but again, it's not the most important. The most important is how we use that. And we know that all the jobs that we have running on the top of that cluster will be created based on our customer needs. So we will be working with our customers on defining all the logic behind our jobs. And the challenge here probably is that we know that our customers will be changing. They will be tackling new challenges. They will be having different approaches. And we have to make sure that our jobs are also changing. And how we do that is probably one of the huge challenges here. There are different ways to do that, but obviously one easy way could be just make sure that when we are creating our jobs, these jobs are changing based on parameters, based on a lot of inputs that our customers could be providing in real time. Let's say that we are collecting data from our access logs or from our request logs, where our customers could be deciding in real time by maintaining a config file what exactly the sites that they want to be monitoring. And they will be making this config file, will be helping them to make our jobs more sophisticated in order to be adding exactly all the APIs, all the sites that they want to be monitoring. They will be deciding what's the important information that they want to capture from each application. They will be deciding even how they want to process that, and even what happened next if they want to be storing that information into a different database or into the same table. So giving them the ability to decide how we want to process every and each of our data flows, it will bring us the ability to make sure that our framework is always changing based on what they require. So the next step, our database, probably is the key component in our framework to be able to achieve real time. So again, different tools that we could use. We have Elasticsearch, Cassandra, InfluxDB to store properly time series databases, time series metrics. But again, the tools are important, but the most important here is how we use them. And in this case, the key component here is how our data will look like inside our database, how we want to create the different standards and the different data units for each specific data source. We could, an example could be continuing with the previous case. If we are collecting data from our access logs, for a specific application, we'll be receiving different messages with all the information of all the requests hitting our servers. In an easy way, we could just parse this, create a JSON-based structure, and insert all the information for a specific site, for a specific microservice into a unique table. But if our servers are receiving, have to handle thousands and thousands of requests per second, what we could expect in minutes, in probably less than 1 hour, is that our table will become gigantic and will be very, very hard to process, very, very hard to define the queries and be able to provide a real-time user experience. So how we solve this situation, how we create a strategy in order to be able to provide the same functionality, the same level of information that our customers expect, but at the same time be able to provide real-time user experience. So there are different options here again, but based on what we explained previously, our customers will be deciding how we want to process that. So instead of deciding that putting all the information into the same table, we could create the automation, for example, to create a different table for each specific API. And our customers will be deciding what's the key information that they wanted to store for each specific API. And they could even decide through the config files what could be the indexers. In this case, for request logs, it's easy to define as the indexers of our database, our host names, our response codes. So they will be adding these complexities, that they will be adding these new functionalities in our config files. But in the end, what we will be able to provide is a real-time user experience, as we'll be creating small tables that will be very, very easy to query against, and they will be very, very easy to combine. And in the end, from our dashboard, we'll be able to provide a true real-time experience. So at this stage, if we look at this framework, what we can see is that technologies are not important here. We could, at any time, be changing our global scale application monitoring system, but just replacing the components that are, that we're using for each specific role. So we could, review what's out there. We'll be reviewing all the changes in the industry and be changing, replacing all the components here to make sure that we're always focused on providing the service that our customer demands, but at the same time, our framework is always changing and is always adapting and using the latest technologies. the latest part, so the final, probably the most amazing part of this journey is our data visualization tools. In this case, Grafana is a good candidate for that. Our customers here will be able to use to create dashboards, to create alerts, to create, whatever you want. But the most important here is you look at the amount of information from different sources that we have in our database. We'll be able to, for example, correlate the results of our synthetic monitoring to what we are seeing in every and each server in our farms or clusters. We'll be able to, when we have a problem, when there is a problem scenario, we'll be able to identify how is this impacting the business, how is this problem impacting the number of orders created by our users. So we have, our users have the power to decide how they're going to manage that and how, and get any information and deep information how our entire system behaves. A few examples of that. If our users are monitoring or are supporting different applications, obviously we'll be able to see in true real time, in few seconds, all the information for infrastructure to response code. We'll be able to route by response code all our requests hitting our servers. But at the same time, we'll be able to correlate number of orders, number of different information that could be important for our business to the hits per second, to different information that we are collecting from different sources. And at the same time, we could do things like checking in real time all the servers in our farm, all the servers in our clusters, and identify different trends. You can see if one server is experiencing a different behavior. And in real time, we'll be able to fix the issues. We'll be able to identify if one server is behaving differently and fix the issue before our customers run into them. You can even follow the same strategy in a different granular way. We could, for each specific APIs of all our services, all our systems, all our microservices, correlate the information to what matters for our business, but at the same time provide information on how our applications behave, and at the same time, you can survey by server identify if, based on different conditions that we could be creating, analyze how every and each server behaves. If we have different teams, like product streams, we have a bunch of different Scrum teams that are the owners of different applications, of different parts of our business. They are the developers that are creating all the applications for a specific part of our business. And they will be creating the services, they will be improving our systems. So that's an easy way to give them access to production environments. They will be seeing in real time how all the changes they're pushing to production, how these changes are impacting our business. They will be seeing how these changes are impacting performance or any kind of changes, or any kind, even for sure, improvements. So we can do this for multiple teams in different ways. But in the end, I think that the most important here, the most important memory from this travel, the most important lesson learned is that we have proof with facts that it's possible align what you think, what you believe, to what you do, the applications that you are delivering to our customers.
And at the end, we want to just thank you all. It's because of your support that every Black Friday and every Boxing Day, we get this massive traffic rushing into our systems, which makes our work so much challenging and exciting. So thank you for being the best part of this journey. We have 5 minutes for questions. Any questions? Yes?
Does that mean you're keeping all your logs for a year? Looking at last year's holidays for this year?
Yes, we do, especially for the major events. We take a backup of them and we keep them for sure. Yeah. Any other questions? Okay. Thank you.
Thank you.
Thank you guys very much, and gals. You know, I'm not sure I like how on top of it you seem to be here. You know, I kind of like the thrill of the holidays, like, oh my God, there's only 3 of those hot pink headphones left. It's Boxing Day, am I gonna get them? Oh, my car crashed, oh. You know, I'll have to settle for the Nighthawk router. Quick, am I gonna get it? I don't know. So, taking away the thrill for me, I just don't know about that. So, one final speaker left for the day, and then we'll sort of move to our open space time. We're very pleased that he could join us. Let's give it up for Jason Hand.
Thank you, Kelly. All right, we're at the so-called finish line, right? So yeah, thanks so much for having me, for inviting me to come speak, and congratulations on another successful DevOps Days. I go to a lot of these. I organize one in Denver, DevOps Days Rockies, which is coming up in just a few weeks. So I love these things, and it's awesome to always be a part of it everywhere I go. So this talk is called Beyond the Mean Time to Recover, or the Mean Time to Repair, Mean Time to Resolve. Lots of different ways you can say that. But for the rest of this demonstration, for the rest of this presentation, we're going to just say the mean time to recover. This is me. I work at VictorOps. VictorOps, you probably heard the 1-minute pitch earlier. We are incident management, on-call management. Those who are on call, you probably use something like us, or you are using us, hopefully to make on-call suck a little bit less. And a good portion of what I'm going to be talking about today is directly related to that sort of role and that responsibility of being on call and trying to keep systems up and running. How many have read this book here, Site Reliability Engineering from O'Reilly? No, not that many. It's actually really, really good. It's very thick. It's very dense. It's written by quite a few people. A lot of engineers got together at Google. The one caveat to this book, though, is that this is SRE at Google. Google has Google problems. They don't have the same type of problems that the rest of us had. But there's a lot of really good stuff in this book. There's some stuff about error budgeting and, of course, MTTR and lots of different things. So if you're in that role of trying to keep systems up, I highly recommend picking up a copy of this. It's actually free. They made it open source, and it's under public license now. So I think it's just google.com/SRE book or something like that. But Google it. You'll find it, I'm sure. But this is a quote taken straight from that book, and from Benjamin Trainer Sloss. The most relevant metric in evaluating the effectiveness of emergency response is how quickly the response team can bring the system back to health. And that is simply MTTR. And a lot of this has to do with just simply trying to keep systems up, right? High availability, high reliability. We want to have as close to 100% uptime as possible. This is sort of the edict that a lot of us are given, and it is the objectives that a lot of us in ops or a lot of us in SRE have. And this is sort of why DevOps kind of exists, right? Our developers are out there trying to push code, quality code, of course, and get it out into production. And the ops people were saying, hey, we're incentivized on keeping the systems up, so we're going to pump the brakes on this whole thing. And DevOps has sort of come around to sort of ease that tension and make things work a little bit smoother and deliver the services to the end users. So a lot of you, like me, probably think, well, if what we're trying to do is keep the systems up, shouldn't we be in more of a defensive tactic and defensive mode, just trying to protect the systems, trying to understand what may or may not be going on, and then try to react maybe beforehand? And so we take the stance of, well, maybe we want to predict things as best as possible and then hopefully prevent that stuff from happening. Because for you, how many people are actually on call? Is that part of your role? So none of us love to be paged in the middle of the night. It's like the worst part of the job. But still, we don't really have, in a lot of cases, we don't really have a lot of people to lean on. And DevOps is starting to sort of shift that a little bit. We talk about moving things to the left. Developers are coming on call now. And a lot of it, is just sort of there to be part of that empathetic message, right? And so, but anyway, back to the prediction and the prevention stuff. If that's sort of the tack you're going to take, a lot of people think, well, shouldn't we be trying to aim for this longer time between failures? Maybe we want to have like days between a failure or months between a failure. And so they aim to sort of engineer in solutions to just keep things from failing. And that's definitely the way I sort of looked at systems administration. It wasn't until I joined VictorOps that, up until then, I was a system administrator. Then I put the pager down and I picked up the microphone, and life's been great since then, for the most part. But anyway, the meantime between failure was definitely the way I looked at it. But then I got involved with this sort of industry and this community and realized that we're not really building simple systems. We're not building even complicated systems in some cases. We're actually building complex systems. And in complex systems, there's a lot of unknown unknowns. There's things that you can't account for. There's things that you cannot predict. And so the main point is that failure will happen. Is there anybody who can tell me today that they work on a system that has never, ever failed, that they didn't build today? John Allspaw is another sort of popular person within our industry, and he's written a lot of stuff. He's actually one of the early DevOps people. If you've ever seen the talk, it's called 10 Deployments Per Day, when he was back at Flickr. I think this was around 2019 at O'Reilly, and this is sort of one of the things that really kicked off the whole DevOps movement. A lot of people didn't know that you could do that or didn't believe that you could do that, this 10 deployments per day. But I love this quote from John. This is actually from his blog. It's called kitchensoap.com. I highly recommend checking it out. But John says, failure cares not about the architecture designs you slave over, the code you write and review, or the alerts and metrics you meticulously pore through. Failure happens. This is a foregone conclusion when working with complex systems. And that's definitely like some serious Kool-Aid that I drank on day one when I started working within this whole DevOps industry. I know for sure, as a former system administrator, as an ops person, that failure will happen. I tried really hard to prevent it, and I just couldn't. And so a lot of it is starting to make a little bit more sense now. On one of the blog posts that John has, and by the way, there are a ton of really good stuff in here about complex systems and sort of the fallacies of root cause analysis, which is a whole other talk that I'd love to give at some point. But he says, in here that it's not that mean time between failure isn't important. It's just that the mean time to recover is actually more important. And there's a quote in here. He's actually quoting someone else that says, "If you think you can prevent failure, then you aren't developing your ability to respond." And that's really true. I wasted a lot of time just trying to harden my systems and trying to keep things from happening. And I didn't even think about getting me and my team poised to respond and react and deal with problems very, very quickly. Whereas it's almost like if you think about sports, you go in and you rehearse and you practice and you do it day in and day out. That's why we have failure injections and game days. We just want to get really, really good at responding to these problems because you can't prevent them from happening. But if we talk a little bit more about some of the kind of popular O'Reilly books out there, this one's another really good one. In fact, a lot of this talk is actually just sort of a glimpse of my sort of reading habits for the past year or so. But mean time between failure comes up here too. It's sort of essential to understanding the availability of a service that you're building. And they state in the Effective DevOps book here that availability is commonly used measurement of how often a system or service is available. Mean time between failure, again, this is used to calculate this, but mean time to recover is also a big part of that. Availability and reliability is really just essentially the result of your teams being able to respond and recover really, really quickly. The DevOps Handbook, this came out late last year. It's another really good book, kind of the follow-up to the Phoenix project. It's mostly a lot of case studies. Throughout it, you're going to see a lot of different things. This is a page that I just happened to flip to that was talking about MTTR. If we heard from Bill at Puppet yesterday talking about the State of DevOps report. This is something that people they kind of have established as the de facto sort of metric when it comes to dealing with incidents. And one of the things that comes up pretty much perennially in the State of DevOps report is that the high-performing organizations, the companies who they have sort of deemed these high performers, they're able to respond to production incidents very, very quickly and quite a bit more fast than some of their low-performing teams, 168 times in the most recent State of DevOps. And you can search the web. You can go on DevOps.com. You can search a lot of Gene's writings. You can go on the VictorOps blog post. Everywhere you go, MTTR, MTTR, MTTR. That's what you want to drive down. Has anyone ever asked you this question here? Yeah. I get this question all the time, and this is my face every single time. What are you talking about? DevOps is culture. DevOps is a mixture of people and process and technology. How are you going to ever put a return on investment on something that has so much of it is just hinged on the cultural piece of it, which is just the people piece? It's very, very hard. How about this question? Has anybody ever asked you this? Some of you system administrators, some of you ops people, has anybody come to you, management, CEO, CTO, and say, what does it cost when we have this type of a problem? These are questions that some of us do kind of sit and think about for a little bit, but then it gets really depressing. So we don't really spend a whole lot of time about it. This is me when somebody asks that. I don't know. But thank you for the State of DevOps report. Again, every year this thing comes out, and there's lots of good stuff in here, but for the first time, 2016, they were able to talk about the return of investment of DevOps. And when I saw that, that's really the first time that sort of an established, now let me back up. I've seen lots of blogs, I've seen lots of articles, and I'm just like nodding my head, nope, 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 through most of those. But when it's the State of DevOps report, I kind of pay attention. I think they kind of know what they're doing. The people over at Dora, Puppet, Chef, all those people, they understand this stuff. And so when I saw that, of course, I'm like, chapter 20, let's get there. Here we go. ROI. Savings includes the cost of downtime and the cost of excessive work. So the very next page, I believe, is you'll find this sort of formula. The cost of downtime equals deployment frequency times change failure rate times the mean time to recover times the hourly cost. This is the first time, at least for me, that I've seen a formula that I can actually associate some real dollar value to some sort of a problem. And of course, at this point, I'm like, wait a second. Okay, here we go. Now we can start calculating some numbers. So let's see what we've got. If we look at the deployment frequency, the change failure rate, and the mean time to recover, we can actually start to see some real costs here associated with the outages. And they could be small outages, anything between a Sev 1 and Sev 5. Doesn't matter, but we can start associating some numbers. Well, let's unpack this formula a little bit and go through each of them one by one. Deployment frequency. This one should be fairly obvious. It's how many times per year does your own org deploy changes, or how often are you deploying new changes to the system and pushing things out. High performers are scoring at about 1,460 per year, whereas low performers more like 7 per year. How many of you feel like you're closer to the high performer? Lots and lots of deployments per year. And then low performers, don't be ashamed, it's fine. Change failure rate. This is another one too, and this is the one that really gets you in a lot of times, which actually is kind of a big part of why we lose confidence in our own ability to do those changes. When we have a lot of failure every time, or not every time, but often when we go to change, we tend to slow things down, and that's sort of counter to what we're actually trying to accomplish with DevOps. But the change failure rate is the percentage of changes that cause an outage of your organization, and then low performers have some kind of problem between 16 and 30%, whereas the high performers are more like 0 to 15%. And then the last two variables of that formula are the mean time to recover and the hourly cost of outage. Real quick, just on the hourly cost of outage, this one's probably the more difficult one to calculate, because then you start having to consider salaries and all kinds of things that you really have to get granular. You probably got to sit down with your CFO and a lot of different management and understand what is our daily cost in a lot of different ways, so we can start associating that with the actual downtime. Not to mention, sort of things like lost customers and bad PR and people going on Twitter and just, rambling on and on. But that's something you have to start looking into and see if you can understand it. And then, of course, the mean time to recover is, the theme of this talk. So, again, back into the state of DevOps, and I know this is really difficult to read, so I definitely highly recommend that you download it, take a look at it on your own. But they started putting some numbers here, and they sort of grabbed a larger organization here, and they said that using the lower number of costs of $500,000 per hour. Now, again, this may not apply to you if you're not in a larger company, but they use this as just sort of a general benchmark. And they were able to say that high performers with downtime cost them about $37,000 per hour, whereas the low performers was more like $2.8 million. Or I'm sorry, not per hour. So the numbers I wouldn't worry about too much here. This is really just to give you an example. And actually, I kind of consider just taking this out of this deck because it's a little confusing. But the point is that now you can start to see some real numbers and what they start to look like. But what is the mean time to recover exactly? What do we mean when we're talking about mean time to recover? Well, the DevOps report says, how long does it generally take for you to restore when a service outage occurs or an incident occurs? And that would be just your unplanned stuff, the things that you weren't really accounting for, not your system maintenance, not your planned maintenance, and that kind of thing. But what does mean actually mean? Because sometimes I think, we hear things, we agree, we nod, we move on. And, some of us may have studied some, math and did some things in college and that kind of stuff, but not everybody really pays that much of attention. So let's talk about mean just for a second. What we actually are talking about here is an arithmetic mean, the value obtained by dividing the sum of a set of quantities by the number of quantities in a set. Essentially, this is just an average. So we're relying heavily on a formula that's just providing an average for us. An average as a metric actually doesn't tell us a lot, doesn't tell us much at all about the individual incidents, and doesn't really give us a clear picture about what's going on. There's certain limitations with this type of number when it comes to averages. And one of those is that within the data set, they're skewed or where outliers are presented. Excuse me, I'm feeling a little tongue-tied. Calculating the arithmetic mean often provides a misleading result. So the main point is that it can't account for the outliers. There's going to be a lot of just really random stuff. There's going to be some really terrible outages, and there's going to be some little ones and some little dinky stuff that you're going to recover from very quickly. And when you're just purely looking at the MTTR, it doesn't have a way to sort of account for that. So you start to see this really distorted picture and an unclear view of what's actually going on when it comes to incident response and how quickly you can get your systems back up. Has anybody ever read a book called Thinking Fast and Slow by Daniel Kahneman? Awesome book, probably my favorite book that I've read in the past 5 years. It's very dense. I would actually recommend listening to it on audiobook. That's how I got through it. But one of the people in there that they talk about is this guy named Richard Thaler. And I'm actually in the middle of reading a book by him called Misbehaving. And it actually, while I was reading that book, is actually when I got the idea for this talk. And it was this quote right here, this little passage where he says, the number of data points, and he's talking about averages, the number of data points can vary greatly depending on the complexity and the scale of a system. Furthermore, averages assume there's a normal event or that your data is in a normal distribution. But anybody who's been on call knows that incidents aren't normal. There's lots of different things that can go wrong, and there's lots of different ways of sort of remediating it, and as a result, lots of different times that might come up in terms of how often or how quickly you can respond to that. So let's look at some actual numbers. These are customers of VictorOps. These are customers of ours who have 50 seats or more, so they have at least 50 people on call. Customers with 50 seats or more, they have 5,600 alerts per day. Now, an alert could be just an information alert, it could be a critical alert, it could be a warning alert. But again, this is an average. And the reason why I wanted to point this out here is that 5,600 alerts per day. Can you imagine your company having 5,600 alerts and you're the person on call to deal with that? That's too much. And the reason why this is so high is that we've got a few customers who have very noisy infrastructure. They've got a lot of alerts, and it's throwing the whole thing off. Same data set, we've got 66 incidents per day. These are critical incidents. These are like at least Sev 3 probably or higher problems that people are having. And again, this is an average. So 66 critical alerts per day, that's something that seems kind of incredible. So I threw this in here just, again, sort of highlight some of the flaws when it comes to like using and leveraging averages. This histogram here shows one of our customers. Their mean time to recover is 40 hours. That's a lot. It's a really, really high number. But it looks like actually a lot of their incidents are recovering quite quickly. It's just that they've had a number of incidents that took a very, very long time, which completely skewed that MTTR. This, to me, is a huge problem if I'm trying to use MTTR as a way to establish a cost of downtime or anything important at all. We advocate for paying very close attention to the MTTR and drive that number down. That's part of your continuous improvement plan. But if your number is at 40, and that's not really very accurate, it kind of, I guess, begs some question as to what are you trying to do. And there's lots of reasons why that number could be high, or there's lots of reasons why that number could be low. In this case, the ones where we saw it kind of skewed to the left, where there's a ton of them, there may have been a lot of incidents that were just auto-resolving. Nagios or whatever you're using, Datadog, may have picked up that there's a problem. Before you even had a chance to acknowledge it, it had already resolved. That happens a lot. Engineers, sometimes I'll get paged, and I'll look at it. This isn't something I know how to do. I'm just, I was the poor schmuck who's on call, but I'm going to hand this off to the person who actually knows how to deal with that. So I'll just go ahead and reroute, and that's going to add more time. The clock's ticking as soon as that incident's created. This one I actually love. It's a little bit sort of controversial, I guess, but a lot of companies, they won't resolve an incident until they have completed their postmortem. Now, someone who loves the idea of postmortems, I like that idea because it kind of holds you responsible to sit down and let's talk about this and try to improve things right now. But then again, your clock is still ticking that entire time. And then there's also this situation. How many have just had some sort of, I don't know, maybe it's your data center, maybe there's something going on and you're like, I know, and you just keep clicking resolve. You're just like, I know, Amazon's down again, it's fine. It's going to be back up. We're going to move on. We're still going to use Amazon. It's fine. Tire fires are just part of the job when you're on call. And these like major outages, these Sev 1, Sev 2 things, if it's an extended outage, this can really throw off your data. It can really extend your mean time to recover and start to sort of muddy up the data, muddy up the number. Okay, so if all that's, hopefully you kind of, you're jiving with me, you understand where I'm going with this whole thing. If that's the case and MTTR isn't, perfectly accurate, what should we be measuring? What's something else? Well, median is very, very helpful when it comes to sort of dealing with those outliers. Now, median is still not perfect, but at least it's something. It's definitely a lot more robust to those outliers. Maximum time to recover, that's another one. Probably not as important, but I think it is sort of, interesting to keep an eye on. How long does it take you to recover? Not necessarily on average, but what's the longest it's taken us? Let's keep an eye on that and try to keep that number going down. The volume of alerts, okay, the severity. How many like Sev 3s are we getting? How many Sev 2s? Sev 2 is something that actually affects the bottom line, affects the revenue. How many of these are we seeing? Are you keeping track of how many of those are happening on a day-to-day basis, week-to-week, or whatever the case is? Total number of outages. This is going to be something that's important to you if you have service level agreements. You probably, have to try to hit that 5 nines, 3 nines, whatever the case is, or maybe you've just got a total number of downtime or total hours of downtime that you're trying to maintain. Maybe you got some flappy infrastructure in there. There's something just going crazy all the time. And it doesn't seem like you can do anything about it. You twist all the thresholds all the time, but you just got noisy hosts and services. This is another one I think a lot of people don't pay much attention to. How often are you paged and it's something that you can't do anything about? That's super aggravating when it's 2 or 3 in the morning, you get that page, one eye open, you're looking at your phone, nothing I can do about it, or it's just not that big of a deal. The hard disk reached 97%. That's great. It's Saturday. They're running reports. It's going to clear itself out. It's going to be fine in 5 minutes. I don't want to be paged on that. Are you keeping track of the unactionable alerts? Also, just the different types of alerts. How about your informational alerts, your critical alerts, your warnings? How many of those are you seeing? It's important to know how many of them are just simply warnings and sort of start, tweaking those dials and try to get things a little bit less noisy. The alert volume per day. Now again, we're back to another average where I always have to say, be careful of this, but what is your alert volume per day? How often are you being alerted per day? That is something you should pay attention to. What time of day? Are you being paged only during office hours? That would be awesome. Are you being paged only in the middle of the night? That wouldn't be as great, but that seems to be sort of the case in most points. But again, keeping an eye on when are you being paged? When is things going off? Is something you should be paying attention to. The mean downtime. This is actually something that until I started putting this together and trying to think of some other things that might be interesting, I hadn't really considered too much. But the mean downtime, what is that? Mean time which the system is down after a failure. Mean time to acknowledge. This is an obvious one. How quickly are you able to actually just acknowledge that you're going to be the one who's responding to this issue? Biometric data. We experimented at VictorOps for a little bit with those of us who had the Apple Watch. What did our heart rate do when we got paged? It always goes above 100. How about sleep disruption? Etsy's kind of famous for their mean time to sleep. They wear Jawbone or something on their wrist when they're sleeping, and they track that data. This is for real. They know how much of your REM sleep is being disrupted simply by being on call. They take a very humane approach to just the role of being on call, which is something all of us should try to learn from. All right, let's get into my final thoughts here. I've got about a minute left. One of the things I can definitely advise is to identify your noisiest alerts and try to address them right now. Don't wait because it's not going to go away. Just address them right now. Bring more people in the fold. We talked to a lot of people at the VictorOps table yesterday and today. We asked them, are you on call? And they said, no, I'm a developer. Okay. Share the load. That's just part of the bringing more people. Shift everything to the left. Let's all understand what's going on. Let's share this. We're building a service. We all are service providers. We're building this together. Share the information. These are just sort of basic DevOps tenets. You know, the CAMS model, culture, automation, measurement, sharing. Share, share, share. Share the load. Share more information. Share the knowledge across things. You can respond and recover much quicker that way. So here's my challenge to you as we're wrapping up. Examine your own mean time to recover. If you haven't started paying attention to that, try to start tracking those data points and see where you're at. And discuss that. And discuss, could this data be skewed? And are we maybe not understanding it in a very clear way? Be very careful of incentive structures. As you know, anything that can be measured can be gamed. So if you tell me I have to hit a certain number, I'm going to hit that number. And that's something that happens all the time, and I don't think we realize it. So the efforts that we're putting to actually improve things may actually not be happening at all. So what's the cost to you, to your organization, by not paying attention to this type of stuff? Or maybe you are. Maybe you're very diligent about that MTTR, but it's actually not telling you what you need to know. And then you're going to be the hero. You're going to be able to take your butt up to management and say, look, I've figured out the ROI of DevOps. This is that one thing that you asked for, a long time ago, and I think I've got it solved. So, one more thing. This is sort of my main message when it comes to any of my talks, and especially anything about DevOps, is that it's really just the idea of continuously improving everything. So, whether it's your MTTR, whether it's just your automation, whether it's your pipeline, whether it's, learning new tools, whatever it is, don't try to boil the sea, don't try to boil the ocean, just make it small and try to just constantly improve over time. And all these things, CI, CD, automation, everything, all that seems to just fall in place. They're all just a byproduct of having a very, very strong focus on continuously improving everything that we're doing. That's all I've got. I appreciate it. It's been awesome being up here in Vancouver. And if we've got time, we'll do questions. Otherwise, we'll get started with the open spaces. We can do them there. Thank you so much. Oh, one other thing. I forgot I threw this up here. It's April Fool's Day, most of us probably know, and I just happened to get an alert that we had posted a new blog post today on MTTR. And so if you get a chance, I couldn't obviously squeeze it all in here, but you should go read this. It's kind of funny on the VictorOps blog, but it's an April Fool's joke for sure. Yeah. Do we have any questions? No. Awesome. That's my favorite. Oh, there's two. Yeah. So when you're assessing the cost of downtime, how do you go about assessing modeling losing a customer? Yeah, that's a really great question. I don't know that we at VictorOps, have ever done that. I'm not sure I've ever. The one thing I will say that we and a lot of companies that I've talked to is we've got some sort of response plan in place. So we have a status page. We can immediately let the people know that need to know what's going on. That can be internally. That can be our customers. We've got our marketing team. They're always on call and ready to start posting on Twitter and wherever else to let people know, hey, we've discovered a problem. We're investigating. Keep paying attention here, and also on our status page. It's sort of that proactive approach. But beyond that, I don't know that I've got any really great suggestion on sort of modeling it or even tracking it. I mean, we definitely know when we lose a customer because of some reason. Customer attrition is something that somebody's paying attention to, I guarantee. But beyond that, I don't know if I have any great specific examples. Is there another one? No, same one? Okay. All right. Well, again, thank you so much, and let's get started with the open spaces, I guess.
Thank you very much. I really like what you said there about people tracking effects of, sleep changes when you're on call and things. That might actually be a good topic during the open space session on on-call empathy. I also liked what you said about change failures, actually. Even high-performing people are experiencing failures between 0 and 15% of the time on their changes. Maybe moving fast or solving difficult problems is hard. So I like what you said there. All in all, that ends our official presentations. Could we give our speakers a big round of applause? You guys did an awesome job today. Right before we get to open spaces, really quick, we have 3 of our sponsors doing giveaways. They're just going to come down here, pull up a name, and give a prize. So come on down, sponsors. Ooh, prizes. Maybe you should have signed up. Maybe I should have signed up. It's true, you asked me, my bad.
Sure, I don't know what I'm doing, but what else is different, right?
You want me to say?
If you want.
Okay. So thanks to everyone who signed up. We had 75 people sign up for the drones, so pretty good odds, I feel like. So I have a spreadsheet, and I'm just doing a random number generator to pick a row, just so we know funny business. So. Number 72. Do you want to announce it? There you go.
Sure. Michael Collins. Thank you very much.
I'm going to draw a sponsor, probably.
Do you want me to hold it for you?
Thank you. Okay. So first of all, thank you all for coming out. Appreciate it. We are going to hand out this very awesome speaker with the Sumo Logic logo on it. So if you don't like sumo, just flip it around this way and you don't have to look at it. Dan, draw me one.
Dan Reichert, no. Dan Carell?
Dan, oh, the last guy to talk to us. Congratulations.
Thank you very much.
Grab all of them. One of us. I'll take the cards out of here.
And our last draw.
Great, so we already did our drawing for the headphones, and it's going to Bill Weiss. He's in the room.
Concludes the State of Prizes survey. All right, now is definitely time for open spaces. For what you voted on for lunch, I'll read out the ones for the first round, and then in between, if you just want to pop into C100 and take a second look, please do that. Again, no need to return to the theater in between. We'll just do our 1 hour and then our 1 hour, and if you want to pop back in, I'll do a quick 5-minute closing, and you'll be on your way for the day. So what we have queued up right now in C225 is Windows-related technologies. You guys know who you are. Get together. Behind us in C485 will be how to do training and knowledge sharing, so sharing best practices around how we're going to do that. In C440 to our left, we'll have Puppet and configuration management. Vincent was going to share a bit about how Salesforce does it, and obviously, you'd be welcome to contribute for how you're doing it too. In C100, the lunchroom and also the room with the sticky notes would be abusing MySQL to make mini Kafka and such. So in C400, over there will be on-call empathy. So if you're thinking like, hey, maybe we should do some sleep tracking, that might be a good place to discuss that. And then in the main theater here, secret management in containers. And that's it for this session. So have at it, have excellent discussions, and we'll catch you at the end of the day.